Hello guys, good evening. How was everybody? I hope we're all okay. Got through the first couple of exams okay. That English went well. I hope Elizabeth Bishop came to your rescue earlier on. So obviously what we're going to have a quick look at, just a quick blitz through a bit of prep for paper 1 tomorrow, right? So what I'm going to do is I'm going to have a look at maybe 3 things. First of all, I'm just going to give you some advice on how to attack the paper, because a lot of you have been asking that. So what's the best approach to take when answering the paper? We'll have a look briefly at what is and is not likely to come up tomorrow. And I'm just going to run through a few bits and pieces with you. We're not going to be doing out full questions. The reason why the notes we're going to be working from here have the solutions in there. I don't want you frantically trying to take question solutions down here, because that means we're going to get through very little stuff. I'll kind of show you some solutions here and point out the important part. That's how I would be getting ready for a maths exam anyway. The night before an exam is not a time to be learning new maths. Okay, or trying to work through full questions, because if you work your way through a full question, writing the solution out, you tend to get fewer of them done. And that means you don't cover as much stuff. So I'm going to try and touch base with every topic on paper 1, have a look at how it might be examined, give you a few examples, and just put the key points back on your radar. That's the basic idea. We'll open up the chat. The chat's closed. We'll open up the chat when I get going here. The reason I don't have it open at the moment is that I know what would happen if we had the chat open at the beginning. I'd get a flood of questions right now, which I'm actually going to answer anyway. Everybody be trying to ask a question now that I'll be dealing with. I mean, you can't say what's like to go up in complex numbers. There's a fairly decent chance I'll look at that when we get to complex numbers in a moment. You know, what do you think? What proofs do you think might come up? All right. What's the best approach to take to answer the paper? These are the things I'm going to be dealing with anyway. So to save you the bother of writing out a question that I'm going to answer anyway, we'll kind of leave the chat off for the moment, and we'll open it up maybe as the class goes on if you want to throw any questions in there. Just as I don't want to get swamped with questions because I'd be answering anyway, because it means we won't get anything done. Okay, so the first thing just to maybe clarify for you is the advice on how to tackle the paper when you get it tomorrow, because a few people asked about that, things like timings and what order to do questions in. Remember that you have to answer 8 questions altogether. Any 5 of the 6 short questions and any 3 of the 4 long questions. So what you want to do when you get the paper tomorrow is read all 10 questions. Spend the first 5-10 minutes reading all 10 questions. Every part of all 10 questions, right? Before you make your choices. This happens year in, year out, that somebody reads the A part of question 7 and say, that looks lovely. That looks like a sequence of series question. I know sequence series, I'll do question 7. And then when you turn the page, when you start the question, turn the page, you realize that parts A and B are sequence of series, but parts C, D, and E are something you're not prepped for. Okay, so now suddenly I've got to scrap this question, do something else, which has used up some of my time, or I've got to continue, push through with trying to answer a question that maybe I'm not fully on top of. So make sure you've read all 10 questions so you know there's nothing hiding in the long grass to catch you out, right? So when you've chosen your 8 questions, do them then in the order in which you're confident in your ability to do so. So what I mean by that is start with the question that you're most confident you can answer. Doesn't matter whether it's a long or short question. Do that one first. And then do the one that you're next most confident in your ability to answer, and so on. So don't kind of say, look, I'll do all the short questions first or all the long questions first. Really, you're probably bouncing between them, doing the questions that you're most confident that you're able to do. Right? The reason I recommend doing that is because remember the normal time allowance, roughly speaking, it's about half the number of marks, the number of minutes. So it's just under 15 minutes for a short question and just under 25 for a long question, though it never works out that way. All right. So what that means, for example, is if you say, look, I know how to do question 2. It's one of the short questions. I'm all over that. That's complex numbers. I'm a tank at complex numbers. I'll do that one first. Okay. Because I know how to do the question, I won't just stop and think and chew my pencil, which means it's not going to take me 15 minutes to do it, okay? It's not going to, or anything like it, okay? It'll probably take me 3 or 4, because I want to stop and think. And all the extra kind of 10 minutes I haven't used yet, that goes into my clock for later on the paper when I'm doing a question I'm not sure how to do, and I may need more thinking time for. It also means if you do your strong questions first, it means you feel you're in the exam early. There's nothing better than kind of doing a few questions at the beginning and feeling I've got those questions right, I've got my score moving here, rather than getting bogged down in a question early on. Okay, that can kind of make you feel like I'm struggling on the paper already. So start with your best question, okay, then your second best question, and work your way through. So if, heaven forbid, you did run out of time, at least that would only happen when you're doing a question that you weren't particularly confident in your ability to answer anyway. Okay, so read all 10 questions, choose the 8 that suit you best, and then do them in the order in which you're confident in your ability to answer them. That's the best way to maximize your score on the paper. One or two people have asked about, should I be doing a 9th or 10th question? And my initial reaction is no. That I wouldn't be going in with that as part of my strategy. Because remember, if you do a 9th question, you do the extra short question, the extra long question, that question's not going to count at all in any way unless you score more marks on it than one of the ones you'd chosen to answer previously. In which case, why wasn't that one of the ones you picked? Right? When you make your selections, when you pick your 5 short and your 3 long, there will be a reason why you chose to leave out the short question that you're leaving out. And the long question you choose leaving out. There's something in there you don't like or you feel less confident in that. So it's far less likely that you'll score better on one of those questions than one of the ones you've chosen to answer. In which case, what's the point in doing it? Right? So if you've got extra time at the end, what I just make sure is that I've attempted every part of every question, every one of the 8 questions I chose. Okay, make sure you've answered your 8 questions that you picked to the very best of your ability. Okay, don't be afraid to try a part of a question the second time if you need to. I did part B of question 7 there. Not sure that's right, that I did the right way. Let me try it again. Okay, remember that your examiner will mark both of those attempts and give you the marks for whichever one earned the highest score. All right, so don't be afraid to try question a second time. So you're much better off spending time trying to make sure the 8 that you've taken on are as good as you can make them than trying to take on a 9th or 10th question. By all means, if you get your 8 questions done and you've got time in the bank and you kind of say, look, there's nothing more I can do to make the 8 I've done any better, then by all means take on a 9th or 10th question. Okay, use up the remaining time by doing an extra question. The only benefit of doing that, remember, is that it just means if one of the questions I've answered didn't go as well as I thought, I've got a fallback. But really that's not going to be the case. If you chose your questions correctly at the beginning, if you made a good choice at the start, that shouldn't be the case at all. That it shouldn't be any help at all. And should I answer an extra long or short? I would base that decision on, which of the 2 sections do you feel that there might be a weaker question. So if, for example, you felt that, look, I've answered 5 short questions, but there's a short question there I'm not really confident with, don't think that went very well, then if I have time to do an extra question, I'll do an extra short question. I'll do the 6th short question, just to give the examiner the option of picking between those 2, what I think are probably my weaker 2 short questions, to come up with my score. Okay? So that's the approach I'd be taking when I'm answering the paper. Just make sure, as I said, this gets asked all the time as well. What happens if I forget to write my calculator make on the inside cover of the exam paper? There's no penalty for that. It's not like your examiner is going to cancel your exam, or because you didn't tell him what calculator you're using, he's going to turn up on your doorstep with a bunch of heavies and beat you up in your driveway. Okay, it's nothing like that. The only reason you're asked to put that into your calculator there is because for some calculator, a very limited range of calculations, depending on what calculator you're using, you might get a slightly differently rounded answer. And your examiner just wants to know that, look, if the difference between your answer and mine is because of a rounding issue, is it because the calculator you're using? So I can just check that. Okay, it's almost impossible to happen, but that's the reason. It's not to catch people out. People who've brought in an illegal calculator, okay, a programmable one, that we're trying to catch those people. I mean, how dumb would you have to be to bring in a programmable calculator and then fall for this examiner's cunning plan where he asks you to write the calculator using on the inside cover, you put the model down there. Right? Dumb ways to die. So it's nothing like that. It's just, if there's a difference in your exam answer and his, it might be because the model calculator you're using, so just that's the only reason you need to know that. There's no penalty if you forget to write it down, so don't panic about that. Okay, so that's how I'd be taking on the paper. And as said, tonight, if you're not going to hang around for the class here, that's perfectly fine. If you want to do your own work, what I would be suggesting, what we're going to be doing here is, if you're looking through questions here, don't kind of feel the need to write out the full solutions. Because as I said, that takes a bit of time. And that means you'll get through fewer of them. If you kind of say, right, this question here, what sort of question is, okay, this is a question with a square root equation. So just in your head, what are the steps? Okay, so I get the square root onto one side, everything else to the other side, square both sides, solve the quadratic I end up with, and then check my answers. Okay, so I know how to do one of those. What's next? So just talking yourself through, this is what you could even do in the morning. Particularly if you don't have geography, you want to do a bit of prep. Maybe have a look at these questions again here and just talk yourself through, okay, so what's the sequence of steps if I get one of these guys? What's the sequence of steps if I get one of these? What are things to remember if I'm doing a question of this type? That's what we're going to be looking at over the next kind of hour and a half or so, depending on how quickly we get through it. And then as I said, if I've got a chance at the end there, I'll throw the chat open and answer any other questions you have. Okay? One thing before we get started, what I have at the back of this hand of the notes there is a list of the proofs and constructions. Now, what I would not be suggesting at all is if you haven't looked at proofs or constructions for paper 1, now is not the time to change your mind on that. Okay, so whatever proofs and constructions you've looked at maybe already, just lean into those. Okay, I wouldn't be doing any more. Remember that you can see at the very back of the handout, okay, the very last page, of the handout. There's the proofs that are examinable on paper 1 and the 2 constructions. So there's 2 constructions. You can be asked to construct root 2 and root 3. So remember to bring your geometry set with you tomorrow if you've had a look at those constructions, okay? And the 4 proofs there, the proof of the sum to infinity for a convergent geometric series, the proof of the amortization formula, the proof of the Moivre's theorem by induction, and the proof that root 2 is not a rational number. Now, you may have had a look at some of those. You may have done none of them. You may have done them all. That's entirely up to you. That's a decision you make. Remember, there's no guarantee there'll be a proof on either paper. There were no proofs on either paper last year. Okay, I suppose it makes it a little bit more likely he might ask a proof of one of the papers this year, but he doesn't have to examine a proof. So spending the night before your exam learning off proofs that might not be on the exam at all is not a great use of your time. If you've had a look at those proofs, great. Just whatever ones you've kind of had a look over, glance over them before the exam tomorrow. But don't try to learn new proofs now. It's not a good use of your time. It's pointless, particularly because there's no guarantee they'll be on the paper. For me, I think maybe the one that's a little bit more likely is the proof of the sum to infinity formula, because it's the only one he hasn't examined yet. It's also quite a short one. Okay, it's possible he might ask the amortization formula tomorrow. Okay, that's a possibility because he might ask financial maths. We deal with financial maths in the course of the class anyway. The last time he examined the amortization proof, the amortization formula proof was back in 2017, and it was worth 5 marks. So the proof is like a page, and it was only worth 5 marks. So again, bear that in mind if you're deciding whether or not to have a look at the proofs or constructions. But they're the 4 proofs and the 2 constructions that he could ask on the paper tomorrow. There's none of them that I feel very, very strongly about. Okay, that I don't have a very strong Peter tingle about any of those there. But as that, I just think the only one he hasn't examined yet there is the sum to infinity formula. So he might tell that, but we'll mention that anyway over the course of the class. So that's the proofs and constructions element. So the reason I said I didn't have the chat open is I know a lot of the early questions were going to deal with that. How should I tackle the paper? What proofs or constructions do you think are likely? So I didn't want to kind of have all the questions coming in when I was going to answer those questions anyway. Okay, so with that in mind, then we'll have a look at a few bits and pieces. So what do I think might make an appearance in different topics, and how would we go about them if they do? Right. So remember, the notes you've got here are all the solutions are done here for you, because I didn't want you frantically writing down solutions here, trying to take stuff down, just so you can kind of follow the steps with me here. So the first topic I'm going to have a quick look at is algebra. So remember, you're probably looking at maybe 2 short questions on algebra in section 1 of the paper. That's usually the case, although your ability to manipulate formulas and solve equations and stuff kind of appears everywhere else. So it's kind of essential to your understanding of any other topic. So you're going to use it everywhere, all right? So the key thing here is, to begin with, simultaneous equations. There's 2 important types of simultaneous equation that you can ask questions on. You've got ones like question 1 here, where there's 3 letters. And you've got ones like question 2 there, where one of the equations contains a square. They're the 2 important ones to make sure you're able to do. Now remember, last year he asked one of these. So last year you got one of those, the one with a square in there. All right. So it's maybe just a little bit more likely that you get one with 3 letters. So simultaneous equation with 3 letters is a possibility there, right? So you can see here in the case of this one here, this equation here, these set of equations. 2x minus y plus 3 equals 0. 3x plus 4z minus 6 equals 0, and 2y minus 3z plus 11 equals 0. You've got those 3 equations there with 3 different letters, but notice each equation only contains 2 letters. So, but none of them contain the same 2. So you've got to try to get down to 2 equations that have 2 letters in there. And remember, you've always got the same 2 options when you're solving simultaneous equations. You can do it by substitution, where you replace something with something else, or you can do it by elimination, getting a letter to cancel. And you can do either of those 2 here. Now, the trick to being good at maths is not to kind of think there's only one possible solution for any question, right? There's a couple of ways of doing it. So, for example, if you tried this question here, you tried to get rid of letters and that wasn't working, let me try it again. Let me just draw a line under that. Don't cross it out because the examiner's going to mark it anyway. Let me draw a line under that attempt, and let me try doing it by substitution as well. See if I get a better answer. Okay, so remember, if you want to do substitution, all you want to try and identify there is a letter that has no number in front of it. So you see, for example, the y in this equation here has no number in front of it. So let me get that letter y by itself. So you can see if I rearrange that, take that equation number 1 there and rearrange it, get the y by itself on one side of the equal sign. So you get y is equal to 2x plus 3. And then just replace letter y in the other equation that contains y with 2x plus 3. And you can see when I put that 2x plus 3 into this equation here, I get this. So I've got an equation now that contains x and z, exactly like the equation that I haven't used yet here. And now I'm in business. Now I can solve the equation that has two equations with 2 letters. So that's one perfectly good way of doing that question there. Okay, just if there's a letter with no number in front of it, get that letter by itself and then sub that into any of the other equations that contain that letter. Okay, that's one way of doing it. You could, of course, do it by eliminating a letter here as well. So although it's not done this way, if you'd say, for example, took that equation there and that equation there, 1 and 2, do you see that they both contain, yeah, those two there. See, they both contain the letter x, for example. The top 2 equations there contain the letter x, right? So I might even take actually the top and bottom, because that might be easier because I wanted to multiply both of them, all right? But if I say, look, if I take the top and bottom equations there, do you see the way that they both have in common the letter y? Right? So if I multiply that top equation there by 4, because that'll give me a minus 4y here, sorry, by minus 2, by 2 I should say, and then we've got a 2y there. So if I multiply the top equation by 2, I'll get 4x minus 2y plus 3 equals 0. I just leave a gap to the z's because there's no z's there. That's multiplying the top equation by 2, and then leave this one alone. There's no x's, so put your plus 2y there, minus 3z plus 11 equals 0. And when I add those two equations together, the y's will cancel, and I get 4x minus 3z plus 14 equals 0, and then solve that simultaneously with the other equation, which contains x and z. See it? So these two equations contain the same letters and can be solved. So the key thing there is that's how you solve simultaneous equations. Okay, you either do it by eliminating a letter or by substituting. All right, that's the way to think about this. So rather than kind of doing this whole question out, just remember the key steps there, right? And once you've solved for one variable, okay, just remember to work backwards and find the values for the other ones, okay? I would normally make sure I write at the bottom. You don't get penalized if you don't do this, but I would normally make sure I write at the bottom there the values for each of the letters, so the examiner doesn't have to go rooting for them. If you don't write that, if he can find your value for x, your value for y, your value for z, okay, he won't penalize you. But I would normally write them at the bottom just to make sure he can see I've got this correct. Okay, so that's one type of algebra quest to make sure you can do, solving simultaneous equations with more than one letter. That's maybe a little, or with more than 2 letters. That's maybe a little bit more likely than question 2. So question 2, remember, is the one where one of the equations contains squares. Again, you've got the same 2 options, as you always do when you're solving simultaneous equations. But when you're dealing with one that contains squares, it's usually impossible to get a letter to cancel. So I'd always be trying to do these ones by substitution. Rearrange the equation that has no square in it and sub into the one that does. So you can see if the 2 equations are x squared plus 2xy minus 7y equals 1 and x minus 3y plus 1 equals 0, take the one that doesn't contain any squares, this one here, and rearrange that. So you can see we've done that here. Rearrange that. You can move the minus 3y and the plus 1 on the left. So you get x equals 3y minus 1. And then sub that in for x in the other equation. And when you do that, multiply the brackets out, you get down to this guy here, and there's your quadratic you're going to solve. Okay, so rearrange the one that has no squares, sub into the one that does, and algebra the shit out of that, multiply the brackets out there, and you get your quadratic you can solve there. And you can see if you solve that quadratic, I get 2 y values, 0 and 1. Remember to sub those back into this line here. Okay, sub those back into this line here. That's already tailor-made to tell you what x is equal to. Okay, so if y is equal to 0, 1, just put those two values back in there and you get the matching y value, matching x values, and just make sure you pair them up. Don't just find 2 x values and 2 y values unless it's very, very clear from your solution which x value belongs with which y value, you'll lose a mark. You have to be very clear because remember these are pairings. So you have to, so if you're going to try and get the equation to work, it has to be minus 1 and 0. That x value and that y value work. Okay, that x value there and that y value don't work. So it's not like you pick either x value or either y value. You must make the pairs very clear. So okay, so make sure you pair up each pair of valid solutions, and that's the way out. And again, I tend to write them at the bottom there. Just make sure you don't have to write them as points, particularly if he's not using that as x and y, if he's using a and b or something. But just make sure it's very clear which a and b value belong together, what the pairs are. Now, it's very probable one of your questions on paper 1 tomorrow will be a simultaneous equations. Okay, one of the short questions, and it could be one of those two there, maybe a little bit more likely that it's one with 3 letters. But once you remember the steps there, okay, how I go about solving simultaneous equations, that's the important thing. Okay, Second thing then I just wanted to point out to you, that's quite common as a short question that we'd have a look at, is factor theorem. And there's kind of two ways the examiner can ask factor theorem on the paper, right? He can ask you to solve a cubic equation, which he did last year, okay? Or he could ask you to do something is a factor of something else type question, okay? So they're the two ways he can ask this. So there was a cubic one last year. Remember that when you're solving a cubic equation like this for leaving cert, remember cubic equation, whenever the highest power of x is, that's the number of terms that that's the number of answers you're looking for. So because it's a cubic equation, that means I'm looking for 3 solutions, okay? So I've got to find 3 solutions. And remember, there's 2 ways this can be done. You have to have one of those solutions to get the question started, right? So the 2 options there are either he will give you one of the solutions, which he did last year. He'll tell you one of the solutions is, or you have to find one yourself by trial and error, right? So remember, if he didn't tell me that the x equal to 3/4 was one of the roots there, if he just said solve this guy on your own here, you would have to find a root, find a number that works by trial and error, which means, remember, just start dropping numbers in here for x until you find one that works, until you find one that gives you an answer of 0. And remember that there has to be at least one whole number that works. That's on the curriculum, that all cubic equations have at least one integer solution, all right? So there has to be at least one whole number that works, and you try and find that using your calculator. And remember, the number you're looking for has to divide evenly into the constant here. So it has to divide even. So the numbers there have to be either 1 or 3. They're the only whole numbers that divide 3, and I'll try plus or minus 1, plus or minus 3. That has to be one of my solutions. Okay, so if he didn't give me a solution, I've got to find one myself by trial and error. Just start throwing in numbers that are factors of this guy here until you find one that works. Okay, but in this case, he gave me one here. So he said, show it's a root. So make sure you do that first. Show it's a root, because he wants to know, do you know what that means? It's a root. Yes, it means if I put x equal to 3/4 here, I do end up getting 0. So just fill in the 3/4 like that and show you do get 0 as an answer. That's showing it's a root. Okay, when I put x equal to 3/4, I do get 0 as a root. And then use that to make a factor. So remember, if 3x, if you solve a quadratic like this, say you're solving this quadratic equation here, x squared minus 5x minus 14 equals 0. Remember your basic steps there that you would have learned back in 2nd year. Open up 2 brackets like that. Factors of x squared are x by x. 14, it's 7 by 2. And that's a minus and that's a plus to give me the minus 5x in the middle. So that'll give me x minus 7 equals 0, which means x equals 7. And that'll give me x plus 2 equals 0, which means x is minus 2. Okay? So remember, so the reason I'm pointing that out is because factor theorem is this. Here, those 2 lines. When you put a factor equal to 0, you get a root. So once you know that, say, if you know that x equal to 3/4 is a root, you have this line here. All you're doing is going back up a line like that to find the fact. It's just those last 2 lines in reverse. So if x equal to 3/4 is a solution, move the number back over on the same side as the x. So if you wrote that as x minus 3/4 equals 0, that's perfectly correct. That's a factor. So if you then divide that factor into the left-hand side of your equation here, and get the answer, that will produce the correct solutions. But just the 3/4 will make the division a little bit messy. Okay? So remember, if you've chosen instead here, look, I've got a 4 below down the left-hand side. If I multiply both sides by 4, I'll get 4x equals 3. So 4x minus 3 equals 0. I'll use that as my factor instead. Okay, so you can do either of those will give you the same answer. And the answer of the top here, when you do the division, will be different, but it'll have a common factor that will divide down anyway. The solution will give you the same. So once you divide, whichever of these factors you're doing, divide those into the left-hand side of your equation, just by doing long division algebra, and then take this answer here and push it equal to 0 to find your 2 solutions. So again, that's how I revise a cubic equation the day before the exam. I don't going to do loads of them out, because I could spend a lot of time getting bogged down in doing long divisions. What are my steps? Find a root. If one's given to me, show it's a root by throwing it in for x. Otherwise, start throwing in numbers till I find one that works. And the numbers I throw in have to be factors of the number on the end there. When I find a number that works, use it to make a factor like this. Do the long division in algebra and then put the answer equal to 0. And you'll notice there's the whole number that works there, minus 1, which is a factor of the minus 3 there. So the 3 solutions there are the 3/4 he gave you, and the other 2 are minus 1/2 and minus 1. They're the answer you get when you put that guy equal to 0. That's how you solve a cubic equation, right? Now again, it's a little bit maybe less likely to ask one. It's not impossible. That the fact that something was asked last year doesn't mean he can't ask it again. Okay, so I wouldn't worry. That's certainly possible. Just a little bit less likely, having asked one of those last year, that he'll double down and ask it again. But it's not too hard to do. Okay, just remember as well, because this is quite a common thing. You're on the paper you get tomorrow. You're going to see a lot of questions you recognize. There's going to be a lot of questions there where you kind of say, "Oh, I've seen one like that. I've done one like that." Okay, I've seen questions like this. I remember how to do those. There's a lot of questions that you're going to say, "Look, I've seen these on previous exam papers." There will always be a couple that you haven't seen before. Because remember, the examiner's testing maths at higher level. So what he wants to say is, look, I don't want people who can just recreate questions or solve the questions that I've already asked. Okay, just kind of recreate solutions that have already been tested on the Leaving Cert paper. I want to see if the guys here can apply what they've learned to a real world problem. Remember question 10 last year with a pattern of dots. Okay, no matter how many past exam papers you'd been through, you'd never have seen one like that before. The maths wasn't terribly difficult. What the difficulty was, you hadn't seen one like that. And there will be questions like that tomorrow. Okay, guaranteed. There are going to be a couple of questions that you don't see before. The key thing there is to trust your gut. Now remember that because you couldn't prep for that question, neither could anybody else. Everybody's going in looking at that question there kind of saying, I've never seen one of this before. So what he's testing there is, can you think on your feet? Can you say, you're having a look at this, okay, hang on, that reads a little bit like a sequence and series question. So maybe I'll try and do something with the sequence and series formulas. Okay, that's what I mean by trusting your gut. You read the question, you get a feel for what the question might be asking you to do, and say, look, I'll go with that. Because a lot of students don't trust their gut. They come out of the exam saying, I read question 10, I thought maybe it was a sequence and series question, but I wasn't sure, so I skipped it. And you're furious when you discover it was a sequence and series question and it wasn't a difficult one. So don't be afraid of questions that you haven't seen before. They're going to be on the paper. Nobody else has seen a question like that before either. And if you've put the work in, you kind of practice your basics are good, you're as well equipped to answer that question as anybody else is. So don't be afraid to get stuck into it. Give it a try. Remember, the more difficult a question is, the more bad the answer tends to be. And as a result, the more generous the marking scheme tends to be. So you probably have to do less on a more difficult question to get the partial credits than you would on one that everybody recognizes and everybody's answering well. Okay, so don't be panicked if you kind of say, I haven't seen one of that before. It's going to happen. It has to. Okay, it's just a matter of kind of saying, okay, well, trust your gut. What does it read like to you? And trust your gut. Right? These ones here, question 4 then. The other type of factor theorem question where you're not solving a cubic, where you're told something is a factor of something else. So if you've been to the past exam papers, you'd have seen kind of 3 or 4 of these in recent years. Okay, it's becoming quite a common question. And there's a few ways of doing this. You can do, when you're told that something is a factor of something else, you can do it by trying to find roots. You can do it by long division, that's fine. But I like this undetermined coefficient method because no matter what kind of question you're asked, this always works. And for me, it's easier to get your score moving in a question like this. Okay, you can start building up marks very quickly if you go about it this way. So you're told x squared minus 12x minus 15 is a factor of x cubed plus ax squared minus 23x plus b. So once I see that is a factor of, I'm going to lock into this idea, this method here. I'll try this method. And we're going to see this now as we go to the rest of these questions here. And what I want to try and familiarize yourself with over the next kind of hour or so is just the language he uses. What are the triggers? What words am I looking out for that tell me how to do the question? Because the paper's full of them. And if you've been kind of doing grinds with me all year, you know, you've heard me say that your Leaving Cert examiner would be the worst criminal in history because he leaves clues scattered all over the place, telling you how to do the question, showing you what needs to be done. He uses words that will tell you what he wants you to do here, right? So is a factor of, I'd be thinking, when I see that phrase, I'd be thinking of this idea here. So if it is a factor of, what that means is if you take the factor you've got, the x squared minus 2x minus 15, right? So take the factor that you're given, and if I multiply that by the other factor, whatever the other factor is, I don't know that, it should equal the right-hand side. X cubed plus ax squared minus 23x plus b, right? So the factor I'm given multiplied by the other factor, whatever that is, should give me the right-hand side. All you've got to get right here is what does this factor here begin with? If you get that right, then actually the rest of this method isn't too bad at all. So all you got to make sure you want to get right here is the first term in this bracket multiplied by the first term in this bracket has to give you the first term over here. That's all I got to get right. So x squared multiplied by what will give me x cubed? This bracket has to start with an x, because x squared by x will give me x cubed. The other term in this bracket is going to be some number, just call it k. So that's the hard part of this question. You're working out what that other factor is. What is the first term in this bracket have to be multiplied by to give you the first term on the right-hand side? That's what this bracket begins with. And the other term would just be some random number k. So that's where I got this x plus k here. And then just multiply out the brackets on this side here. That's what I've done here. So then multiply out the brackets on the left-hand side. And notice, because you were careful about what you chose here, that means that the x cubed on this side matches the x cubed on that side. See it? The x cubed terms match. That means the x squared terms have to match, the x terms have to match, and the constants have to match. So I would just write those three equations down now. Take what's in front of the x squareds on the left-hand side. That's k minus 2, see it? So in front of x squared there we've got k minus 2. And put that equal to what's in front of the x squared on the right-hand side. That's equal to a. So k minus 2 equals a. There's one of my equations formed. That's just putting what's in front of the x squareds equal. What if I put what's in front of the x's equal? See it? Minus 2k minus 15. That's in front of the x on the left-hand side is equal to minus 23. That's on the right-hand side. There's my second equation. And then what's left, minus 15k equals b. That's the constants. So there's my three equations there. And if once you've written those three equations down, if you've done this correctly, if you look at one of those equations should let you work out what k is immediately. See by the top one there, minus 2k minus 15 equals minus 23. That's all. The only letter in there is k. So I can use that to find what k is. K is 4. And then by subbing k equal to 4 in the other two equations, you'll answer the question. So that's the method here that if you see it is a factor of, if you work out what the second factor is, multiply the brackets out, and then just put what's equal in front of x squared on both sides equal, what's in front of x on both sides equal, what's left over on both sides equal. Those are the equations that you're going to end up solving to find your solution. And if you've done that correctly, one of those equations will immediately let you work out what k is. The k you introduced here, you should be able to work out what that k is equal to, and then sub that k into the other two, and your solutions will emerge out of the mist. Okay, so you can see here, if I put k equal to 4 in this one, I get 4 minus 2 is equal to a, so a is 2. And then put k equal to 4 in here, I get minus 6 is equal to b. Job done. Okay, so that one's not too bad. See the second one on the next page, same idea. Slightly more complicated one, but the method doesn't change. Again, look at that same phrasing, is a factor of. So x squared minus x plus p is a factor of 2x cubed plus 2x squared minus px plus 4. So again, same setup. The one I'm given, x squared minus x plus p, multiplied by the other factor, whatever the hell that is, should equal the right-hand side. The 2x cubed plus qx squared minus px plus or. Right? So again, what does that second factor look like? What does it begin with? Well, remember again, this term here by this term here should give me this term here. So x squared multiplied by what will give you 2x cubed? That's a 2x. X squared by 2x will give me the 2x cubed to make sure the x cubed terms match on both sides. And then the other term in there would just be some number. Let's call it k. So again, once I've established that the other factor is 2x plus k, again, just multiply the brackets on the left-hand side, like that. And then put that equal to the right-hand side. And again, notice the x cubed terms match. Because I was careful about these two here. So because the x cubed terms match, the other ones will match as well. So put what's in front of the x squareds on both sides. So the x squared there is going to be what k minus 2 is equal to q. There's one of my equations. Okay, x's minus k plus 2p is equal to minus p. There's my second equation. And then what's left, pk is equal to or. There's my three equations. I'll just write those down first. Put what's in front of the x squareds, x's and numbers equal to one another in front of them on both sides, put them equal to one another. And then one of those should let me work out what k is. You can see it does. This one here. Okay, the one where I'm comparing coefficients of k. You can see that minus k is equal to 2p. So if I rearrange that, I get that k is equal to 3p. Okay, there's only two things in there, k's and p's. So k is 3p. So put 3p in here and put 3p in here. And that's where your two solutions come from. So that's probably maybe a little bit more likely tomorrow because he asked the cubic equation last year. So we might get one of these tomorrow, okay, as a possibility. And again, notice that once I've got that method there, okay, it's not too hard to lean into. Okay, so that's just a little bit more likely there in factor theorem. So that's simultaneous equations, factor theorem, two things to make sure I'm okay with for algebra tomorrow. Then just a couple of kind of loose ends to finish that up. This one here, the one on the question 5, a square root equation. He asked one of these now back in 2024. Didn't ask one last year. that very often now he kind of mixes around between modulus equations or inequalities and square root ones. Okay, so he might do the square root tomorrow because he didn't ask that last year. He asked the modulus inequality last year. So this one you remember, squared equation. Again, just remember the sequence of steps. Square both sides to move the square root sign. So bring everything that's not a square root onto the right-hand side and leave the square root on the left. So square on one side, everything else on the other, and then square both sides. Just remember when you're squaring this side here, treat it like a bracket. Be very careful of that if you square the right-hand side here, when you square that, you don't just get x squared plus 9. That's a bracket. Okay, always, when you're squaring both sides of the equation, always treat both sides as brackets. Okay, so you're going to get x squared plus 6x plus 9 like that on the right hand side, and the left hand side the square and square would just cancel. So when you bring all your like terms together, you get a square root, a quadratic equation like that, and then just solve that by factorizing or by using your minus b formula, and I get 1 and minus 3. And then remember, for square root equations, check your solutions. You will only get 7 out of 10 if you don't check your solutions. There's only 2 types of equation on paper 1 where you have to check your solutions to get full marks. Equations that contain square roots and equations that contain logs. And we have a logs one coming up now in a second. They're the only 2 where you must check your solutions. And when you're checking your solutions, put these 2 numbers back into the original equation, the one that was given the question. And when you're taking square roots, the square root of 16, always just take the positive number. So when you're checking your solutions, root 16 is 4, not minus 4. Okay, root 9 is 3. Again, I'm not going into the reasons why now, because tonight's not about teaching you maths. It's just about kind of putting these methods back on your radar, the key steps involved here. So for a square root equation, square on one side, everything else on the other, square both sides, treating the side that doesn't have a square root as a bracket, get the equation you end up with and solve it, and then check your solutions in the original equation that was given in the question to see if they work or don't work. Okay, in this case, both answers work, so there's 2 solutions, 1 and minus 3. If one of them didn't work, cross out the one that didn't work, or you won't get full marks. Okay, so that's how you solve a square root equation. Just one tweak that he hasn't examined, slightly more difficult. See this one here on page 9. Again, there's where you kind of say, look, what happens if we got one like this that we haven't seen before? Because he hasn't examined this in the Leaving Cert papers in the past. Okay, well, trust your gut. It's a squared equation, just square both sides. So you can see here, because there's 2 separate square roots and a number, okay, what I can't put kind of everything that's not a square root on one side, really, okay? So just in this case here, I have square roots on either side like that. Again, I'm going to square both sides, right? So you can see on the left-hand side, you get 3x minus 2. That's fine. Square and square will cancel. But again, when you square this side here, that's a bracket, right? So it'll be root x minus 2 plus 2 multiplied by root x minus 2 plus 2. And again, multiply the brackets out. Root x minus 2 by root x minus 2, that's just x minus 2, yeah? Because it's root x minus 2 squared, all right? Now notice here, root x minus 2 by 2 is 2 root x minus 2. There's another 2 root x minus 2 when you multiply those 2 together. And then 2 by 2 is 4. So do you see where I've got that then? I can bring these like terms together here. And that's where I got that line there. Right? So x minus 2 plus 4 times, bringing the like terms together in the middle here, 4 times root x minus 2 plus 4. And now, now we're down to one like the previous question. So when I squared both sides, I got rid of one of the square roots, but I didn't get rid of the second one. There's still a square root in there. But now it's the same as the question we did a moment ago. Right? So now I'll just move all of these guys here over onto the left-hand side, and I get this line here. 2x minus 4 is equal to 4 times x, and now square both sides again. So it might be necessary to square twice. If you've got an equation like this where there's 2 different square roots in there and something else, squaring twice might be necessary. Okay, so just keep your eye on that. That's a possibility. But then once you get there, it's the very same idea. Get down to the 2 answers down here, 6 and 2, and again, check your answers for full mark. So it's possible we could get a square root one tomorrow because he didn't ask that last year. Just make sure you've got the sequence of steps there. Square both sides, solve the quadratic you've got, and then check your solutions. And when you're checking your solutions, take the positive square roots only. Now, just before we move that, just remember that if you're solving a modulus equation, one like this, okay, that's the one he asked last year. Okay, that it was a modulus inequality, but the same idea, you did the very same thing. All right, if you're solving a modulus equation, again, you can just square both sides. So the reason why he kind of switches between the two. So to solve a modulus equation, just square both sides as well, right? Because if you square the left-hand side here, remember when you square a modulus, the modulus means if you get a negative answer, drop the minus sign. But when you square something, you can't possibly get a minus answer anyway. So the modulus symbol becomes irrelevant. So the modulus and the square don't cancel. The square means the modulus is irrelevant. So I can ignore the modulus symbol altogether here and just say, look, that's just x minus 5 squared. So once you decide to square both sides, you can just ignore the modulus symbol, then square this side here. So you get your x squared minus 10x plus 25 equals 9. And again, bring everything on the same side and solve. And you don't have to check there. There's no square root in your equation, so you don't have to check. Obviously, if you check when you don't have to, there's no penalty. So if you're not sure whether you should check or not, do it anyway. Because in a question where you don't need to check, you just ignore the fact you checked them. All right, but in a question where you do need to check them, if you won't get full marks as you do. But you only have to check your equation, your solutions, if it's a square root equation or one with logs. So that's just those two there. So normally he'll ask one of those two, either a modulus or a square root equation. He asked the modulus inequality last year, so it might be the square root one this year. Just again putting this. So this is what I mean by I'm not making predictions here, okay? Because that's a fool's game. You know, sitting here predicting what's going to be on the paper. You can't do that. The examiner is going out of his way to avoid patterns, because remember, the idea is if he gets into a pattern or a routine of any kind, where he says, for example, let's say he says, look, I'm only going to examine induction every second year. He gets into that pattern there. What that means, in every off year, teachers won't bother teaching induction. They say, look, it's not going to be on the paper, so why would we waste classes teaching it? So he wants to make sure that everybody learns the entire course every year. And the only way to do that is to be unpredictable. So the examiner is not going to, the fact that he kind of examined something last year doesn't mean he won't examine it this year. Or the fact that he didn't examine it last year doesn't mean he will examine it this year. So I'm not making predictions here, saying, look, I think it's going to be one of these. It's just in all likelihood, okay, that in the case of this here, that's why I'm doing both. Okay, I'm not just doing the square. We'll have a look at both of them, but I just think it's maybe a little bit more likely he might ask the square root. But that's not a prediction. It's just kind of saying, look, looking at what he's done in the past, I don't know whether he'd leave it 3 years without testing a square root equation. So don't think of these as predictions. It's the reason why I'm trying to cover everything here as best we can. Right, guys, question 6 then. The quadratic inequality. To almost test this every year in some shape, fashion, or the other. It can even come as part of long questions. Just remember when you're solving a quadratic inequality, again, what are the steps? Well, if I bring everything on the same side there, you can say I get x squared minus 6x minus 16 less than 0. And all you do there is you treat this as an equation and solve it as an equation first. So if you're solving a quadratic inequality, change the inequality sign into an equal sign and solve the equation first. So I just solve the equation and I get minus 2 and 8. They're my two critical values. Remember, that's the term for those. You don't need to use that term. The examiner won't use it, nor will you be expected to, but they're called the critical values there. And the solutions to the inequality then, it's either all the numbers in between these guys in the number line, like that, or all the numbers that are not. It's everything below this guy, everything above that guy. All you've got to do now is check which. Now, there's a few ways you can check which. I know some of you guys do it using the shape of the graph. That's perfectly fine. I tend to do it just by testing a value. So you see the way in this case here, there's my two values there. There's minus 2 down there, and there's 8 up there. So I'm going to pick 0, because 0, you don't have to pick 0. I'm picking 0 because it's easy to work with. And 0, you'll notice, is in between minus 2 and 8. You don't have to pick a number that's in between them. You can pick any number you like for any part of the number line you like. Just pick any number to test. 0 works nicely, right? So I'll just test 0, because if 0 works, and what I mean by works is if I put 0 in here, the statement is true. If 0 works, then all the numbers in here will work, and that's my solution set. If 0 doesn't work, then none of the numbers in here will work, and that's my solution set. So just by testing a value, I can work out which it is. So I put x equal to 0 in the original inequality here, right? You can see, and when I put the 0 in, the terms with zeros just disappear. I get minus 16 less than 0. That's true. So 0 works, which means that's my solution set there. All the numbers in between them will work, and I'll just write that as an inequality. You won't get full marks if you leave it as a diagram like that. You must write your answer as an inequality. Okay, so it's everything between minus 2 and 8, and that's written that way. Okay, if it was these numbers here, I would tend to write that this way. So it's the numbers x less than minus 2, that's these numbers here, and x bigger than 8, that's those numbers there. And you start to get a bit pedantic about this. Try and put that union symbol in between, because it's those two sets of numbers combined. It's not either or, okay? It's both those, so make sure you put that symbol in there. It's not wrong to write as an inequality with the number, these signs pointing in the opposite direction. I don't do it that way, simply because it's too easy to get the signs jumbled up when the two answers look the same. So in this case here, you know, it also suggests, does it not, that it's just one set of numbers. It's not. In this case here, your solution is two separate sets of numbers combined. So I'd write it that way. So pick which set of answers are your solutions, and then write them as an inequality. Okay, that's the idea there. So that's how you solve a quadratic inequality, and it's on the paper more often than not. Just this one here, part B. He hasn't examined one of these now since what? I think it's 2018. The last time he examined one of these, a fractional one, right? So it's the very same equation again. It's just a matter of how you get down there. So if you're trying to solve this inequality here, x plus 2 over x minus 1, less than or equal to 2, first of all, it doesn't look quadratic. But the key thing here is what you've got to do first, remember, is multiply both sides by the denominator squared, not just the denominator, right? If you have an equation like this, let's say you've got 4x over x plus 2 equals 5, then obviously to get rid of the fraction, I'll multiply both sides by the denominator. So I'll multiply this side here by x plus 2, and that side there by x plus 2. And then these guys will cancel, and I just get 4x on the left is equal to 5x plus 10 over here. And you can see I can solve that now. That's no problem. All right, that's fine. But if it's an inequality, 4x over x plus 2 is less than 5. If I multiply both sides by x plus 2 there, I'm going to get the low partial credit and nothing else. Because I've made a mistake, and that mistake has made the question easier. So if you make a mistake which simplifies the question, you'll get the low partial credit, right? Remember, the key thing, the difference between solving an equation and an inequality is if you multiply both sides, multiply or divide both sides by a negative number, the inequality sign flips. And that could be negative. That's the reason that's a mistake. You can't just multiply both sides of an inequality by x plus 2 because it could be negative, and that would flip the sign. So if you multiply it by this squared, you know for sure that the equation is it's positive, because squares are always positive, right? So make sure you remember that if you're solving the inequality fractional one, you multiply both sides by the denominator squared. And when you do that, you can see it boils down to a quadratic inequality like the one we just did. Okay, it'll boil down to a quadratic like that, and then you can test your values accordingly. So you can do the rest of the question the very same way, but it's just how you get there. So you multiply both sides by the denominator squared. You can see if you multiply both sides by the denominator, you just get an inequality that looks like that. So it's not quadratic. So you've made the question much easier when you made your mistake. That'll pull you down to low partial credit. Okay, so just keep your eye on that. That's the fraction inequality. So they're the key things in algebra I'd be having a look at. Obviously, I can't go possibly do the entire course with you in one evening. I'm just touching base with the kind of things that the examiner tends to examine. Okay, and that's more likely to come up tomorrow. Just to put this back on your radar. All right, we can't possibly do the entire course, so we're being a little bit selective in what we do. So I'm just going to have a quick little run there through logs and indices, just show you kind of one question each of those before we start moving to calculus. And maybe when we get to the ends of indices and logs, I might open the chat up for a minute or two, just see if there's any questions on that. Bearing in mind though, guys, if we open the chat up, I'm not going to go off on a tangent, if you'll forgive the pun, because we've got calculus coming up. And I start answering questions that have nothing to do with what I'm dealing with right now. As you can see, I've dealt with a lot of the questions on how to attack the paper, proofs, stuff like that. I've talked about predictions. Obviously, the topics that I haven't looked at yet, we'll look at when we get there. So it's just if you have any kind of questions about kind of algebra or logs, indices, you want to throw it at, you can do that. I'm unapologetic, if you don't mind, going to ignore any questions that don't deal with that. Okay, because I don't want to get sidetracked here. I want to try and get as much covered with you as I can in the next hour or so, and just see where we are. All right? So question 7 then. The key thing to make sure what's becoming quite popular now is in short questions where you got to use the rules of logs and indices. And remember, they're on page 21 of your formula booklet. So page 21 of your formula booklet, remember it's this page here. Okay, so there you go, page 21. You've got your rules of logs and your rules of indices. Rules of indices down the left-hand side here. Okay, and then the rules of logs here and here. Now, there's a lot of them. There's actually 3 important rules I'd make sure I remember. Okay, because most leaving cert questions can be done with those 3. Okay, so the 3 that I'd make sure I remember when we're dealing with indices like this Remember, you've got this one here. That if you've got a number to 1 power and you multiply that by the same different power, you just add the powers. That's your first rule of indices. All right. If you've got a number to 1 power divided by the same different power, subtract the powers. Right. If you've got a number to 1 power raised to another power, multiply the powers. They're the 3 most important rules of indices I'd be familiar with. Right. The rules of logs are more common. We'll talk about those now in a second. But they're the rules of indices. Okay, the 3, and you can see they're kind of listed for you here. So we're asked to solve this equation here. Now, he hasn't asked one of these in quite a while. Okay, when was it 2021? He had the last time he asked one like this. Okay, where the key thing here is, look, this is a difficult question. And the chances are maybe not everybody's going to get this one right, even if you're quite good at maths. But I don't want to get 0. So remember, what will make a big difference to your score tomorrow is those questions that you're not able to answer. There's probably going to be some of those. I don't know how to answer this. Okay, can I avoid 0? Okay, I've spoken to the guys who've been doing grinds with me all year. This idea about crawling through the pack, right? That if you can imagine when all the paper ones that are done tomorrow are all marked, if they're stacked in order of size, in order of score, okay, score, the lowest score is the bottom and the highest score is the top 10% of that pile will end up getting H1s. To stop the grades going off a cliff. The marking scheme adjustments and the post-marking adjustment will make sure that everybody in the top 10% gets a score over 90. Okay, so even if you've got like 74% on the paper, the marking scheme will make sure that ends up being a score of 90 or more to make sure the top kind of 10% get H1s. The top 25% will be H1s or H2s, I would imagine. Okay, if we're going to keep roughly in line with previous years, even maybe coming down slightly from previous years, the top quarter of the pile will get H2s or H1s. So what your plan tomorrow is to try and do everything you can to get your paper crawling up to the pile. So let's say you're doing this question here. A lot of people will leave this one blank because it's tough. I'm not sure I can do this. So if I can even do a step in the right direction, use any one of the rules of indices there to simplify any part of this, that should grab me partial credits. That moves my paper higher in the pile, which improves the grade I'm going to end up getting. That's your mentality. That's how you want to approach this. Remember, what the exam tomorrow is, it's an opportunity to flex. I know it doesn't feel like that. But you've spent the last, well, not just the last 2 years, the last kind of 5 or 6 years, from first year to 6th year, just learning maths, getting better and better at this subject. So tomorrow's a chance to show the examiner how much you've learned. I know it might not feel like that, but that's what it is. I mean, if you've just done leg day in the gym, what do you do immediately? You're over to the mirror to get a mirror selfie, right? To document your gains. Tomorrow's an opportunity to show your mathematical gains. Look what I know how to do here. Okay, I don't know how to do this entire question, but look what I do know how to do. That's your idea here. That's how you start building a score. Don't be afraid of this and leave questions blank, okay? The examiner wants to give you marks. Give him a reason to. So if you look at this here, I mean, the first thing I'll notice here is that, see that 6 to the power of 1 there? Well, that's just the number 6. So I'm not going to get too worried about that. So look at this one here. 6 to the power of 2x plus 1. Can I use the rule of indices to pull that apart? Well, the answer is I can. Remember this rule here. A to the power of m plus n. Right? So I've got a to the power of m plus n is a to the power of m multiplied by a to the power of n. So look at it, if I write down this one here, 6 to the power of 2x plus 1. See it? I can just replace m with 2x and n with 1. So I get 6 to the power of 2x multiplied by 6 to the power of 1. That's just 6 times 6 to the power of 2x. Now, if I don't do anything else, there's partial credit. There's 4 to 10. Step in the right direction. That's the plan. Guys, that's how you build a score tomorrow. I'm not afraid to try it. Okay, I've learned a lot of maths here. I just want to show the examiner how much I've learned. Okay, that I haven't learned enough to answer this question fully. I'd love to be able to do the whole thing, but I can't. But I can do a bit of it. Okay, so give me some marks for that at least. Right? So you can see if I do, the key thing with this one here, see this one, see the power of 2x. Look at this rule here. Right? So 6 to the power of 2x. I can write that as 6 to the power of x squared. Or 6 squared to the power of x. They're the same thing. But this one here, see, because it's 6 to the power of x here, I want to be able to find that and then remove it, replace it. Because all this is, it's a quadratic equation in disguise. I just want to be able to see the question I end up with. So rather than kind of wading through the entire solution very deeply here, it's just how would I get my foot in the door if I got an awful one like this, right? So you can see this is an awful question here, tricky one, would be very badly answered, but the examiner will reward people here who give it a go, who give it the old college try. So you can see if I use the same idea here, 6 to the power of 2 plus x, see it? I can write that as 6 to the power of 2 multiplied by 6 to the power of x. Okay, so that's just 36. So you can see all I've done is just replace those out here. So the equation looks like this then. Or I get down to the equation that looks like that. Okay, so this guy here is just 6 times 6 to the power of x squared. That's 6 to the power of x, and that's 36 times 6, so that's 37 times 6 to the power of x. And I've got the plus 6 on the end there. That's what I end up with, okay, when I use my rules of indices. And now it's easy, because now it's just a quadratic. I can take out the 6 to the power of x, replace it with a letter, and you can see just there's the quadratic I end up with. Solve that to get your two values. And then finally reverse the substitution. But a question like that is going to be quite hard to answer, all right? Just as I said, don't be afraid to give it a try. So if you can show the examiner, look, I can actually use any of these rules here. If you can show evidence of being able to use any of those to try to simplify this equation here, you're going to get your partial credits. Don't panic if you don't think you can finish the whole thing. Okay, just try to go as far as you can with the rules of indices and just don't leave it blank. The next one, the rules of logs here, same idea. There's 3 important rules of logs. There's this one here, that one log plus another can be written as the log of these two multiplied together. One log minus another can be written as the log of this guy divided by this, a fraction. And then the log of log multiplied by something like that, you can pull this number up here and write as the log of a power. Right, again, there's your 3 most important rules of logs. And then the one that's becoming quite important now, how to change base. I'll show you that here. So there are your rules of logs and rules of indices, the most important ones. Okay, so if you've got a log or index equation, an exponential expression or equation, or a log expression or equation, and you want to kind of try and make a stab at simplifying it, try and grab these rules here and see if you can apply any one of them. Okay, they're always kind of tricky questions, these guys here. They're always difficult questions. So you'll be rewarded here for trying something, not being afraid of it, right? So the key thing to notice here, look at the equation here, log to the base 3 of n squared minus log to the base n of 27 equals 5. The first thing you got to remember is in order to use any of these 3 rules here, the bases have to match. So check that first. And they don't. That's a log to the base 3, that's a log to the base n. Okay, straight away, I know I have to change the base. And if I just do that and nothing else, there's my partial credit. So have a look and see, if you've got an equation or an expression that contains logs, do all the bases match? If they do, I can start trying to use these guys here to tidy it all up. If they don't, change one of the bases. Make the bases match, right? Because that's going to be your first step, and the examiner's going to be delighted with you there. You're going to say, now the examiner's your fan. So excellent, this person knows that changing the base was necessary and has an idea how to do it. So how do you change the base? Well, if you've got one like this, let's say you've got this here, log to the base 6 of x, and you want to turn that into a log to the base 3. Because maybe the other logs in the equation are 3s, all right? So how do you change that? Well, all you do, if you want to turn this into a log to the base 3, just make a fraction and put the log you want to end up with above and below the line. So we're trying to make this into a log to the base 3, put log to the base 3 upstairs and downstairs, and whatever's up high here goes above the line there, and whatever's down low here goes below the line there. That's how you change a base. That's all there is to it. Right, so you can see for this one here, okay, I want to change, so I can change this into a log to the base n, or that into a log to the base 3 so they match. It's always a better idea to turn the bigger base into the smaller one, or change the one that's not a letter into one, the one that's not a number into a number. So I'm not going to turn this into a log to the base n, I'll turn this into a log to the base 3. Okay? If they were both numbers, like if it was log to the base 3 of x minus log to the base 9 of 2x something, I would turn that into a log to the base 3 rather than the other way around. It's not wrong to do it the other way, it just becomes a little bit more complicated. Okay, so like an extra line or two. So turn the bigger number to the smaller number, or turn the one that's not a number into a number when you're changing the base. So you can see all I got to do here to turn this into a log to the base 3, make a fraction and put log to the base 3, what you're trying to end up with above and below the line like that, and put what's up high here above the line there, and what's down low here below the line there. There we go. Base changed. That's all I've done here. Okay, and you can see what's above the line there, that's just a number. You can put that into your calculator. Log to the base 3 of 27 is just the number 3. So that's just done using your calculator there, and now we can tidy it up. And you can see now, look at this, there again, there's an equation like the previous one. So what I can do now is I can take out that log to the base 3 of n and replace it with a letter. I get a quadratic, solve the quadratic, and then reverse the substitution. So both those two difficult questions are both quadratic equations in disguise. So in this case, you want to find the 6 to the power of x to replace. Here you want to find the log to the base 3 of n to replace. In both cases there, I use my rules of indices and logs to rewrite the equation until I can see the exponent that's in every term, or the log that's in every term, and then take it out and replace it with a letter. When I do that, I get a quadratic I can solve. And when you solve the quadratic, then reverse the substitution. Okay, take the letter back out, put the log back in, the exponential back in, the exponent back in, and solve what you end up with. So again, it's possible you might get one of those. I just think it's a little bit maybe, they're difficult questions. I wouldn't be expecting them to be very well answered, but just don't be afraid of them, guys. Don't be afraid to get stuck in and have a go, right? So I'm going to start moving to having a look at calculus here. We will take a break shortly anyway. Okay, calculus is the other kind of big hitter. Then I'll have a look at some of the smaller topics towards the end. I might just open up the chat very briefly there. If anybody has any questions on algebra, as I said, unapologetic, guys, if we fire open the chat here, I'm going to ignore any questions that deal with with stuff that's not what we're working on right now, right? But just if you have any question you want to fire in the chat now, you can do so. If they're related to algebra or along these lines here, as we start heading into calculus, right? So we've done the algebra there already. Thank you, Grace. Thank you very much. So question 9, then we're starting to move into differential calculus, the other really big hitter. The discriminant is possible. That the discriminant, again, he could ask a question on the discriminant. He could, I guess, ask a question on the binomial theorem. All right. So boom. Look at this. Everybody in the world is just has just asked a question there. Whoosh, bang. Yes, so I'm not going to answer any questions, stuff that's coming up here. Okay, yeah, look at this. Hello, woo, wee, whoosh, bang. Yeah, all going there, right? This is great. Look at this. Okay, so the entire world is throwing in there. The questions actually come scrolling there so quickly I can't even read them. Okay, so they're all kind of blasting through there. So yeah. Here we go. Can I avoid logs? You can avoid anything because you've got choice in the paper. Okay, so there we go. Okay, so I can't even read the question there. Maybe Grace, everybody's a little bit excitable, so maybe just knock the chat off there for a second, because actually there's no point. They're coming in so quickly now I can't even read. Thank you. Okay, we might try that again in a minute. Okay, just there was so much coming through there. I couldn't even read the question. They were scrolling through so fast. I saw a lot of people kind of saying hello and thank you, and that, I appreciate all of that. But let's just kind of focus on the maths here, because that was crazy. If you could see that here, literally coming in so quickly, I couldn't even read them. All right. So we'll do a bit of this maybe towards the end when I've got the bigger hitters done. And we'll try it again if anybody has any questions they want to filter in here. Obviously, I can't look at the entire course. I can't cover everything. I'm prioritizing stuff that the examiner tends to examine, or that he might examine tomorrow. I'm not saying that if I don't cover something here, it's not going to be on the paper tomorrow. I'm not saying the stuff I'm covering here will be. We're just trying to have a look at the basics here and how you would go about doing this. So if, for example, I think Rowan threw in something there about the discriminant, which I like, Rowan, and thanks for that. All right. If I'm not doing a discriminant question here, here's how I would look over the discriminant in the morning, if I get a chance. Find a question involving the roots of a quadratic equation, discriminant, and just talk yourself through the steps involved in solving it. Don't try and do the whole thing out. It just gobbles up a lot of your time. Just pull out a question that has that. Same with binomial theorem. If you're going to do a binomial theorem, although he asked the binomial last year and completing the square, we predicted those for last year. He asked them. He could ask them again. But because they were on last year's paper and we're limited in time here, I've just chose not to have a look at those this evening. But again, if there's anything in there that you say, look, I want to have a look at that myself, this is how I would do it. Just pull out a question maybe you've already done, and rather than trying to write out the solution again, just pull out the steps. What are the basic steps here, right? So calculus, remember that calculus, differentiating from first principles, okay, the sequence of steps are in there, remember. He doesn't ask that every year. He didn't ask one last year, so again, it's always a likely question when he hasn't asked the previous years. There was no first principles question last year, so he could ask it here. Just remember the sequence of steps, work out what f of x is equal to, then what f of x plus h is equal to by replacing the x with x plus h and algebraing the shit out of it, okay? Then subtract one from the other, so take this answer here and subtract the previous one, the top line, okay? Divide by h, and then put h equal to 0. And if you remember those 5 headings there, they're not in your formula booklet. What's f of x equal to? That's given the question. What's f of x plus h equal to? Replace x with x plus h and multiply it all out. Subtract one from the other. F of x plus h minus f of x. Divide by h. And then get the limit as h approaches 0, which just means replace h with 0. Remember those basic steps, because the tendency with this is it's not difficult to do, but students tend to skip lines because they know what the answer is supposed to be by using their shortcut. So just try and make sure you fill out the entire thing there. Okay, so follow that sequence step so you won't leave out a line that's necessary. Just remember, you would have had to multiply the brackets out here first. Okay, so remember, he can only ask you to do first principles for x squareds, x's, and numbers. If there are brackets, you have to multiply those out. You can't use the product rule or anything here because you're trying to use first principles. Okay, so I need that sequence of steps. So just have a look at that. Remind him of the steps there. It's possible we could get first principles because he didn't ask one last year. Again, when people ask what topics can I leave out, I would now never recommend leaving out a topic no matter what grade you're looking for. So because I'm just looking for H5, H4, H6, what topics can I leave out? I wouldn't be leaving topics out. What I'd be doing is I'd be cutting back on the amount of detail I do in each topic. So I'd have a look at each topic, but I'd do them to less depth. So for example, in calculus, if calculus is not your thing, and you're looking for, like, say, look, H4, H5, H6, try and make sure you can do first principles, because that's not too hard. Try and make sure you can do this. Turning points, points of election, because that's not too hard either. All right? Maybe the really difficult differentiation that we have a look at the moment, kind of trickier max-min problems, or doing difficult logarithmic differentiations, or inverse trig, or something like that. Leave those out. Cut those back. But make sure you've got the basis calculus, because in a topic like calculus, not only does it mean I'm not skipping it, but the stuff that he examines is usually the easier stuff. Okay? So to find turning points, there's 3 important things to remember when you're trying to find turning points. So it says a graph function is defined as f of x equals minus 1/6 x cubed minus x squared plus 16x plus 32 over 3. There's my function. Find the coordinates of p, the local maximum, and q, the local minimum. So find the local maximum and local minimum point of the curve. Now you absolutely must know how to find maximum and minimum, those turning points. Okay? How to find turning points. Okay? Don't you dare go into paper 1 tomorrow without knowing how to find turning points. Don't you dare. Right? It's very easy. See it? To find a turning point, derivative equals 0. Absolute doddle. So all I got to do is differentiate this and put it equal to 0. No problem. That's not hard to do. So you can see, again, just the fraction cause problem. So 3 times minus 1/6 is minus a half. So multiply by the power, drop the power by 1. So I get minus a half x squared minus 2x plus 16. That's my derivative. Okay, when I differentiate this and then put it equal to 0. And there's a quadratic you can solve. Now, in the Leaving Cert marking scheme, it will very often look like that. And your question is, how the hell do you get from here down? What he'll very often do is, if there's a number like this in front of the x squared, he'll divide across by that, because very often they become whole numbers. Absolutely, you don't have to do that. You can use your minus b formula. A is minus a half, b is minus 2, c is 16. You will get the right answer, you will get full marks. There's no requirement you simplify this. Just if I did divide across by minus a half, I get this quadratic here, which solves very easily to give me 4 and minus 8. Okay, so just put your derivative equal to 0, no problem. Absolute doddle. So remember that it's too late now. I've been telling people all year that that's so important to get a tattoo. You're not going to find a tattoo parlor open this late on a Thursday evening, and I'm not sure it'll be dry anyway tomorrow. You can't look at it in your exam if you've still got the cotton over it. Okay, so there's no point getting this a tattoo now. You've blown that play. It's too late. But remember that's how you find a turning point. Derivative equal to 0. Okay, and it's not hard to do. They find those two, and then remember, when you find the two x coordinates, sub them back into the original function, the one given, always back into the original function to find the matching y values. Okay, so there's my 2 turning points. It's minus 8, minus 96, and it's minus 448. There's my 2 turning points. So put each of these 2 x values back into the original form to find the matching y values, and there's your 2 turning points, right? So absolutely simple math, and it's on the paper nearly every year. Just depends on whereabouts. Is it part of a short question, part of a long question? Just make sure you can do that. Maximum or minimum, to find a turning point or a maximum or a minimum. I mean, if he uses the word maximum or minimum in a real world problem, same thing. Derivative equals 0. It's just an application of calculus. So the word, add those to your dictionary for tomorrow. Maximum or minimum, derivative equals 0. That's what he wants me to do when he uses the word maximum or minimum. Or turning point, derivative equals 0, because they mean the same thing. Okay? So then, remember, to show what sort of turning points they are, all right, you must use the second derivative test. So remember, if the second derivative is positive, it's a minimum point. If the second derivative is negative, it's a maximum point. That would have also been a tattoo, but you know, too late to get yourself tattooed now. Didn't listen to me when it could have made a difference, so it's too late now. All right, so that's how you check what sort of turning point it is, right? And remember the reason why. I want to spend a bit of time on this. Remember that if you've got a graph like that, a cubic graph like that, right? That the first derivative dy dx tells you what direction the graph is heading in, up or down. If it's positive, the graph's going up. If it's negative, the graph's going down. So in this graph here, right, all along here, dy dx will be positive because the graph's going up. All along here, dy dx will be negative because the graph's going down. And then all along here, dy dx will be positive again because the graph's going up. So the first one tells you what direction the graph is heading in. And notice at this turning point here, at these two turning points, these two guys here, right? Remember that turning point there, the graph is not going up or down. It's switching between them. That means dy dx is not positive or negative. That means dy dx is 0. Not positive or negative. That's how that works. That's how you find turning points, right? So the turning points are based on that. If you look at the same graph, the second derivative, d2y dx2, the second one, okay, tells you the shape of the graph, not the direction, the shape, okay? If it's positive, the graph is U-shaped. If it's negative, the graph is N-shaped. That's what the two of them tell you, right? So notice here that if it says if the second derivative is negative, what does that mean? It means the graph is N-shaped. And that means the turning point has to be a maximum point because that's all N-shaped graphs have. So when you work out the second derivative, you're working out what shape the graph is, which will tell you what sort of turning point it is. It's the only reliable way of doing it. There are other methods that people have been asking about all year where I test values on either side and see if it's going up or going down, or we'll look at the shape of the graph. Nothing else is as dependable and simple as this. So that's how I would always show what sort of turning point it is. Check the second derivative. Positive, it's a minimum point. Negative, it's a maximum point. So I just found my second derivative by differentiating this guy again. Take this guy here and differentiate him again. Right, and when I do, I get this. There's my second derivative, minus x minus 2. And if I sub that x value in x equal to 4, I get the answer minus 6. That's less than 0, so it's a maximum point. So 448 is a maximum point. And then always test the other one. Don't just say the other one must be a minimum. So put the minus 8 in here. I get 6 is my answer. That's bigger than 0, so that's a minimum point. So those two parts of the three important things in calculus. Okay, in turning points. How to find turning points, derivative equals 0, and how to test what the turning points they are. Second derivative positive, minimum point, because the graph is N-shaped. Okay, the graph is U-shaped. Okay, second derivative negative, maximum point, because the graph is N-shaped. Okay, but that's what a lot of people don't realize. And there have been a few questions. In fact, there's one coming up where he's really testing that. So you can see all along here, in this graph, the second derivative is negative because the graph is N-shaped. Okay, and then all along here, sorry, change color. There we go. All along here, the second derivative is positive because the graph is U-shaped. So notice then in between them, there's a point here where the graph is neither N-shaped nor U-shaped. It's switching between them. That's your point of inflection. And how will you find that? Well, look, the second derivative is not positive or negative here. It's equal to 0. That's how you find. So that's what part 2 is. How do you find the point of inflection? The second derivative equals 0. There's the 3 pieces of your toolkit. That's how you do turning points, points of inflection stuff. To find turning points, first derivative equals 0. To find points of inflection, second derivative equals 0. And to check what sort of turning points they are, second derivative positive means it's a minimum point, negative means it's a maximum point. Okay? Say that 3 times before you go to sleep tonight. Make sure it's in your head. So if I put the second derivative 0, I get minus x minus 2 is equal to 0. That gives me x equals minus 2. And then again, sub that back into the original formula to get the matching y value. And it's minus 2 minus 24. And remember, for cubic graphs, the point of inflection should end up being halfway between the turning points. So you can just check that. Don't find it that way, but you can check it that way. Okay? That's perfectly fine. And then part 3, it says t is a tangent to the graph at the point where x equals 3. So t is a tangent to the graph at the point where x equals 3. Find the angle that t forms. So remember, when you're told that you're dealing with a tangent to the graph, so remember you've got your graph that looks like this, and you've got maybe a point here and got a tangent like that. The two things he can ask you there, he could ask you to find the equation of that tangent, which he did last year, right? He could ask you to find the equation of that line there, or he could ask you to find the angle it makes with the x-axis. Okay, because they both kind of test the same maths, right? So to find the angle here, remember the key thing we're dealing with here is to find the angle that it forms with the positive x-axis. He's asked this question on the leaves paper like 3 times. Find the angle a tangent forms with the x-axis. All you got to remember is that if you've got a line like this, right, the slope of that line is equal to the tan of that angle. The angle you're looking for, the tan of theta. So if theta is the angle that any line makes with the x-axis, the tan of that angle is equal to the slope of the line. Why? Because look at the slope of the line here. How would you get the slope of that line? It would be this rise over this run. That's how you get the slope. How would you get the tan of theta? Opposite, this guy here, over adjacent. Same fraction. So that's all you're testing here, that the slope of the line you're looking for is equal to the tan of theta. So remember, the derivative dy dx tells you what the slope of a tangent is at any point in a graph. So if I take my derivative, which we found earlier on, the minus a half, that minus a half x squared minus 2x plus 16. So we took our derivative there, put in x equal to 3, as we did there, we get the number 11 over 2. That's the slope of this line here at the point where x equals 3. So if you put an x value into into dy dx, you're finding the slope of the tangent at the point where x equals that value. So the slope of the line is 11 over 2, so that means the tan of theta is equal to 11 over 2. So theta is then the inverse tan of 11 over 2, and that gives me my answer 80 degrees, and that's what you're looking for. Okay, remember, if he asked to find the equation of the tangent, no problem. Remember, it's just, you use the formula y minus y1 equals m times x minus x1. So he gave you x1, he gave you the point x equal to 3 there. You just found m. M is the slope. So either way, that's what he's testing. Can you find the slope of the tangent at that point by putting the x squared of the point into dy dx? Because dy dx is the slope of tangent at any point on the graph. All right? And then all I need is the y value here. So again, you can see to find the matching y value, take that x equal to 3 and put it back into the original function. It's always the original function to find y values, because that's the only formula that tells you what y is equal to. And then fill them into the equation, simplify, that's how you get the equation of a tangent. Now that's very, very common maths on paper 1. Okay, so finding turning points, points of inflection, that kind of stuff there. Just make sure you got that in your toolkit. And then part 4, the diagram below shows part of the graph, y equals f of x. Remember, he's asked 1 or 2 like this now in the last couple of years. The point S, which is k, f of k, lies on the graph between the points q and r. Okay, so q, remember, is the minimum point, and r was the point of inflection. We found those earlier on. Which of the following combinations is true? So look at where you're at the diagram here. The point we're looking for, the point S, lives on this part of the graph here. Right? So what he's asking there is which combination is true? F of k is positive, f of k is negative, f double dash, remember, so f prime of k is the first derivative, f double dash or double prime is the second derivative. So first derivative positive and second one positive, or the first one negative, second one positive, first one positive, second one negative, or they're both negative. And he's just testing this idea here. Do you know what the two derivatives are telling you? Right? So remember, look at the part of the graph we've got here. The part of the graph is increasing, is that the graph's going up. Okay, so the graph is going up, or increasing if you like. That means the first derivative is positive. Remember, that's what that tells you. It tells you about the direction. So if the first derivative is positive, the graph's going up, negative, it's going down. So we know the first derivative is positive because the graph is going up. What shape is the graph? It's U-shaped. Okay? The graph is U-shaped. That means the second derivative is also positive. Remember, that's what that means. Second derivative positive means the graph is U-shaped. So we know that they're both positive. That's this combination here. That's why I take that. And that's my explanation. I don't need any more than that. So that little bit we did there about, what the first, second derivative tell you, that'll probably come in useful somewhere. Okay, just remember what the first and second derivatives both tell you in terms of shape of the graph. Okay. Second question, I'll come back to question 11 in a second. Let me just do question 12. So question 12, 13, and I think 14. Yeah, these three here. I'll blitz through these, and then I might Grace and I, we might just have a look and see if the chat is still batshit crazy. Okay, again, we give it a second go because it's fun if nothing else. It's like a ticker tape. All right, but we have a look in a second. But these three here, remember, your long questions on paper 1 are very often applications of functions. So we'll give you a function that models a real world application. And he can ask you a few questions there, which we'll have a look at here, but he can build calculus into those as well. So we'll have a look at these three here, because this is a big chunk of the paper done once we have a look at these. And then it's just kind of smaller topics beyond that. We'll have a quick look at integration, complex numbers, sequence of series, and financial maths. Okay, so once we've got these guys done here, right? So we get the smaller ones from that point onwards. So application of functions here. You can see what the question is here. So somebody asked, I think somebody, my eye just caught one question as they were blasting past me at a rate of knots. It was almost like watching one of those high-speed Japanese trains go past you. You know, somebody held up something at the window. I just caught one bit of the window there. I missed everything else. Okay, so somebody asked, will I be doing some long questions? Ta-da. All right, so we have a good one or two here. So it says the concentration of a drug in a patient's blood after administration of a specific dose can be approximately modeled by the following function. So f of t is 6t over 1 plus t squared for t values bigger than 0 and t negative 4, where f of t is the concentration in milligrams per milliliter, t hours after. So if I'm doing this in a leaving cert question, I'll just write in there. So t, that's in hours, because he told me it was, and this is in milligrams per milliliter. Right? He just told me that f of t is in milligrams per milliliter and t is in hours. I'll show you why now. Because see what the question does then. It says, look at part 1. It says, find 2 times when the concentration of the patient's bloodstream is 1.8 milligrams per milliliter. So look at the number given in the question. 1.8 milligrams. So because it's in milligrams per milliliter, it has to go in here. It's a value for f of t. So that's telling me what he wants me to do, how to set the question up. So just because I've written in beside the 2 variables what they're measured in, the units tell me where the number needs to go. So just want to solve that question there. So you can see, just multiply both sides by 1 plus t squared to remove the fraction. Okay, and on the left-hand side, you get a quadratic to solve, and your 2 values are 1/3 and 3. Very easy once I know what the question was asking me to do. So if you're doing a functions question like this, it's very likely there'll be functions, application of functions, but maybe even 2 questions on this in the second part of paper 1. Okay, it's always likely that you get application of functions. Just when you read the information, you're writing beside the 2 variables what they're measured in, because that'll tell you where to put numbers he gives you in the question. And once you put the number in here, once you do that line there, you get your low partial credit, and then you can see what it is you're being asked to solve. Right? Just be careful here. See what it said? I give your answers in minutes. So remember that these t values are in hours. So I've got to multiply by 60. So it's 20 minutes and 180 minutes. Very, very easy question. So the 2 normal types of question he will ask you is, he'll either give you a number to put in this side here. Suppose I asked to find what's his blood concentration after 6 hours. So because in the question I mentioned 6 hours, because that number's in hours, you know it's going in here for t. So I just put 6 in here and pop it into my calculator. Okay? Second version of the question where I put a number in the left-hand side and solve the equation I end up with. That's what we've got here. The other 2 then to be careful of, look at this one here. There's another buzzword. Add that to your dictionary for tomorrow. Rate. Rate means derivative. So if he asks you to find a rate, he wants you to differentiate and then probably sub in a number. So I know now I'm being asked to differentiate this. Whether or not I can do it now doesn't matter, but at least I know what to do. And again, guys, write that down where the examiner can see it. Because at the past marking schemes, if you show him that you know differentiation is necessary, he'll give you the 3 out of 10. You're not getting 0. Don't be afraid of this. So I recognize what rate means, right? So you're kind of telling him there, look, I know that rate means find the derivative. I haven't a Scooby how to find the derivative, but I know that's what you wanted me to do. So you get the low partial for that. Okay, so show him you understand that. And obviously because we're trying to differentiate 6t over 1 plus t squared, that's a quotient rule. So that's just a little application of the quotient rule there. Remember, you call what's above the line u, what's below the line v, differentiate the 2 of them separately, and then fill them into the formula which is on page 25. So that's on page 25 of your formula booklet. And tidy it all up and you get this guy here. Right? So just pop into your quotient rule there. That's a quotient rule differentiation. Again, you know, you either know how to do that or you don't. Okay, the quotient rule. A lot of people leave the quotient rule and product rule out if they're not looking for a top grade, and that's fine because they don't get examined very often. All right, but that's how you would do it in this case here. And it says after 90 minutes. Right? So you've got a value to sub in. Again, be careful. See if I check here, I know that t is in hours. I flagged that at the very beginning of the question. The number he gave me to throw in here is in 90 minutes. So don't throw in 90. It's 90 over 60, so it's 1.5 hours. Convert 90 minutes into hours, 1.5 hours, sub in the 1.5, and you get that answer there. Minus 0.71 milligrams per liter per hour. Okay, it's okay to put it down as milligrams per liter per hour like that, but milligrams per liter, milliliter hours, if you're familiar with how to operate units, that's perfectly fine. Okay, but that's your answer there. So again, rate means derivative. You do the differentiation and sub in a value. Make sure you've got that word in your toolkit. It will be on the paper somewhere tomorrow, guaranteed, and it means derivative. Okay, and then look, here we go. We already have this in our toolbox, don't we? There's that word maximum. So maximum means derivative equal to 0, and I'll tell them that. So when you recognize these words tomorrow, underline them, write down in the box what they mean. That's going to get your low part, and then have a go at doing it. Okay, then into doing it if you can. Okay, so find your, we've got the derivative already. Because it means derivative, we've got the derivative, put it equal to 0. There's the equation there. Multiply both sides by this guy here to remove the fractions. All right, and you get 6 minus t, 6t squared equals 0. Solve that, you get t is equal to plus or minus 1. Cross out the minus 1, because remember we were told in the question that t has to be bigger than or equal to 0. So we cross out the minus 1, it means t is equal to 1. And sub that in there, and you get this value here. So t is equal to 1, sub it in, and you get 3 milligrams per milliliter. Now, just wanted to point out here, I put my derivative equal to 0, and I solve the equation I end up with. So I get t squared is equal to 1, which means t is plus or minus 1. I'm crossing out the minus 1 because that's not possible. T is equal to 1. So there's my that's like finding your x value for a turning point. How do you find the matching y value? Put your x value back into the original formula. Not in here. Always back to find, when you find a turning point, when you get your x value, in this case your t value, put it back into the original formula, the one given in the question, to find the matching y value. That's what I did here. And I got the answer was 3, and it's 3 milligrams per milliliter. Okay, now, do I have to show it's a maximum point? Because I said find the maximum. Remember, how do you check what sort of maximum, what sort of turning point it is? Put your second derivative equal to 0. Now, in the case of this question here, you won't be penalized if you don't. Why? Why won't I be penalized if I don't here? Because one of the turning points for this graph isn't possible in the context of the question. The minus 1 here makes no sense. So there's only one valid point here, turning point in the domain we're dealing with. So that must be the maximum we're talking about. Now, in an exam, particularly if I'm looking for the H1, what I would tend to do is, when I'm doing a max-min problem, I would usually go ahead and prove it's a maximum point anyway. I don't take any chances. Okay, I'm going to go ahead and confirm it's a maximum point. The only drawback here is, notice, you'd have to use the quotient rule again. You get your second derivative. And then put the number 1 in and show that you get a negative answer, so it's a maximum point. Okay, that's a bit of work. So if you were kind of saying, look, just to be absolutely safe in my head, I'd like to show it's a maximum point. I know that's another quotient rule. Make a judgment call. Do you want to do that now? Or do you want to say, look, I'll go and finish my paper, and I'll come back at the end. I'll just get the derivative here, second derivative, put in the number 1 and show it's a maximum point. I'll just come back and do that at the end when I've got time, rather than getting bogged down in doing it now, because that's a bit of work. But in the case of this one here, you wouldn't be penalized if you didn't do that, because there's only one valid turning point in the domain we're dealing with, so that must be the maximum he's talking about. It couldn't be anything else. Okay, that's a nice little question and worth reminding you of. Okay, second application of function graphs. Again, this is kind of do a little bit of work with logs indices. Okay, just an exponential one. Exponential functions, he tests these quite a bit. There was kind of, remember there was kind of a little B part on this in a long question last year. It's been a while now since he asked a full long question on exponential functions. Okay, so exponential functions he quite likes because there's a lot of good maths in there. And hasn't asked as a full long question, although it was on the paper last year, hasn't asked as a full long question in a while. So might kind of do it again this year. Okay, we'll just have a look here. So again, the change in population of an animal over time can be roughly modeled by the following function. N of t equals 117 times e to the power of 0.075t. So n that's the population. So there's no units for that because it's population. There's no units for population, but that's in months. T is in months. So t months after observation began. So part 1, find the population 15 months. See it? So because it's in months, I know that's a value for t. Okay, so because t is in measured months, I'm just going to put 15 in for t. So put t with the 15, solve it down, and I get 360. There's 5 very easy marks to get me going. So that's a very common starting question when you're dealing with a functions question. He'll just give you a number to throw into the function and get an answer. Okay, 5 easy marks to get you started. All right. I round that one to a whole number because we're dealing with a population. Remember, you can't have 0.4 of an animal. So in that case there, you won't be penalized if you round that to a whole number because it makes sense in the context of the question. Okay, you might on a bad day lose the mark if you don't round it to the nearest whole number because we're dealing with a population of animals here and it can't be a decimal. Okay, so to be safe there, I think I'd round that to the nearest whole number. Part 2, how long does it take the population to reach 1,000? So again, that's a population. The population is 1,000. So again, that goes in here. There's that question we started the previous one with. Put a number in the left-hand side and solve the equation you end up with. Right? So I put the 1,000 on the left-hand side. I get 1,000 is equal to 117 times e to the power of 0.075t. Remember the sequence of steps there? Divide across by this number first, and don't bother putting it into your calculator. So I get 1,000 over 117 is equal to e to the power of 0.075t. And now how do I remove the letter e? E to the power you remove using natural log. So you get rid of e to the power, you take the natural log of both sides. So the natural log on this side here, the natural log and e to the power will cancel, and just leave the 0.075t behind, and put that into your calculator. The natural log of 1,000 over 117 is about 2.146. Then divide by the 0.075, you get 28.6, and put your units in, times in months. You lose a mark if you don't put in the units. If you don't round correctly, or if you leave out the units, you lose 1 mark. You won't lose marks for both. So if you rounded incorrectly and left the units out, you still lose just 1 mark. So we would penalise rounding incorrectly, or leaving out units, or both, with a 1 mark deduction. Okay, look at part 3. There we go, sports fans. There's our special word again, rate derivative. Fine. Now it's worth just kind of doing this question just to remind you how to do the derivative. Okay, I know any of you guys have been doing calculus with me all year, know what you're going to hear now. Know the 3 words I'm going to be saying out loud now. Okay, so when I'm asked to differentiate a function like this, so 117 e to the power of 0.075t, okay, for any differentiation of a function like this, I'd be thinking number, function, bracket, okay? So you've got the number in front here, right, the 117, you've got the function, okay, which is the e to the power of, and you've got the bracket, which is the power, right? So number, function, bracket. So to find your derivative, n dash of t or dn dt, whichever you prefer, they're both correct. They're fine. Okay. The number just stays put. 117 stays where it is. Page 25 will tell you what the function turns into. Because when you're differentiating, and page 25 is where the calculus shortcuts are. So I go to page 25 here. Page 25, you can see it. What happens e to the power of when you differentiate it? It stays the same. So it's page 25 we're dealing with here because that's where the derivatives are. When we're differentiating, we use page 25. Okay? So e to the power of stays the same. So the e to the power of 0.075 will stay the same. And then finally, you multiply by the derivative of the bracket. That's the chain rule. That's the chain rule. Looks like an operation. Okay? That function bracket bit. So if I differentiate 0.075t, I get the number 0.075. That's how you find your derivative. Number stays put. Page 25 will tell you what the function turns into, and then multiplied by the derivative of the bracket. Number, function, bracket. That's where I got that line there from. And I just multiplied these 2 numbers here together, tidy that up to get this 8.775 times e to the power of 0.075t. That's my derivative. And then just shove in the number I'm given, 8, and you get this. It's 16 per month. So you put 8 into the formula here, into this formula, you get, again, nearest whole number, 16. Remember, it's these units per those units, right? So n is the population. What's that measured in? Animals. And t is the time in months. So you could write down here 16 animals per month, but because animals is not a unit of measurement, an SI unit of measurement, you can leave that and just say 16 per month. So again, because that's positive, it means the population is going up at a rate of 16 animals every month. It's the rate at which the population is increasing. Okay? So if that was minus 16, it means the population is declining. The number of animals is going down by 16 per month. We've met this already. Positive means going up, negative means going down. Right? Way back here, we met that. Positive means going up, negative means going down. Okay? This same idea again, this guy. Positive going up, negative going down. Okay, so watch out for that word rate. Okay, it means derivative sub, and if you're doing an exponential or a logarithmic function, or any of those, okay, remember it's number, function, bracket. Now, just to kind of preview of forthcoming attractions, okay, average value. Find the average population. That's another buzzword. Add that to your dictionary for tomorrow. Okay, average, remember, means integrate. Okay, it's the integral divided by the interval width. Okay, so anytime you see the word rate, we know what we're going to do. We're going to find the derivative, shove in a number. Anytime we see the word maximum or minimum, we're going to find the derivative and put it equal to 0. Anytime we see the word average, we're going to integrate and divide by the interval width, as I'll show you now. This is the language he used to tell you what he wants you to do. So if you recognize these terms, guys, you're in business. Okay, at least you'll be able to write down what the question wants of you, and you'll at the very least get your partial credits. Don't be afraid to get stuck in. And if you look over the past exam questions, look at how often these words are used to tell you, here's what I want you to do. And there's so much maths in your head, guys. All he needs to do is release the Kraken. He just needs to let you know what he wants to do. That's your problem, is you have all this maths in your head, and you're just not sure, well, what does he want me to use here? These are the words he uses to tell you what he wants you to do. Average value means integrate. So remember, integration, well, I have to integrate here. It says for the first year. So for the first year, because t is in months, it's from 0 to 12 months. Not 1 to 12. The first 12 months starts at time 0. Okay? So if it's over the first hour, it's 0 to 60 minutes. Okay? Over the first week, it's 0 to 7 days. Okay? So the first year is 0 to 12 because we're talking about months here. All right? So you want to integrate this function here between those two. So again, when you integrate, it's the same thing. Number, function, bracket. So anytime you're differentiating or integrating, just remember this little shortcut here for tomorrow. I'm sure you'll be able to use it probably a couple of times in the paper. Number, function, bracket. So again, number, function, bracket, like we had up here. But when you're differentiating and integrating, there's two very slight differences. So first of all, number, as usual, the number stays there. So whether you're differentiating or integrating, if there's a number in front, just leave it there. Function. What do we do when we're differentiating? We went to page 25 to see what the function is, because that's where our differentiation shortcuts are. When I'm integrating, I'll go to page 26 instead, because page 26 is where our integrals are. See it? So page 26 over here, see what it tells me, that e to the x, when you differentiate that, or when you integrate that, it also stays the same. So when you're trying to work a number, the number just stays put, whether you're differentiating or integrating. Function. If you're differentiating, go to page 25. See what the function turns into. If you're integrating, go to page 26. See what the function turns into. So in this case here, the e to the power stays the same. Okay, so it's e to the power of 0.075t. And if you're differentiating, you multiply by the derivative of the bracket. If you're integrating, divide by the derivative of the bracket. Like that. There we go. And that's where I got that line there. Number, function, bracket. It's worth having spent a minute. Again, any of you guys who have been on the platform with me all year are dab hands at that now. You're doing that with your eyes closed. Okay, we've been working on that, kind of working that little trick, number, function, bracket, all year. If you haven't done class with me before, it might be new, but it's a nice shortcut here. Okay, rather than getting bogged down and trying to use the chain rule, that's what it'll always look like. So differentiating number, function, bracket, the number stays put. Page 25 will tell you what the function turns into, and multiply by the derivative of the bracket, because that's the chain rule. And if you're integrating, the number stays put. Page 26 will tell you what the function turns into, because that's what the integrals are, and then divide by the derivative of the bracket. That's how you'll do those two, right? So again, that's my integral there. And then all I got to do is sub in the two numbers. So put the number 12 in here first, the bigger number in there, put 12 in there first, and I get like 3837. Put the smaller number 0 in next, I get 1560, and subtract one from the other. So that's your integral there. If I integrate, I work out what the integral is, and then sub in the bigger number first, the 12 in first to get this number. Small number 0 in second to get this number, subtract one from the other. Right? So that's your integral. Then to get your average value, you've got to divide that by the difference between these two numbers here. So 12 minus 0 is 12, so divide the answer by 12, and I get 190. Now, when I was doing this with the Grind to 60 crowd, I know a lot of you guys meet it that way. Yeah? That you get this, when you're getting an average value, you get this out in front. That's the division there, just done all in the same step. That's perfectly fine. So the 1 over b minus a is the division. Just a lot of students aren't sure when to divide and when not to. You divide like this, or put that in, when you're finding an average value. Specifically that word there. Otherwise, you don't divide. If I was just asked to do the integration on its own, okay, just this thing here on its own, That will be my answer. 2277. I only do the division because I'm asked for an average value. I divide by the difference between these two values here. That's my average value. Now that's differentiation integration of an exponential function. Again, always worth having at the back of your on your radar, because these differentiation integrations happen on the paper all the time. Okay. Last one, then we just take, as I said, I'll just for my own entertainment, I'll throw up in the chat and we'll just see if the comments go past me like a Japanese bullet train. All right. I'll maybe try and grab one or two words as they fly past me before Grace, inevitably, bless her, has to slam down the chat again. We'll try it again in a moment, but just when we have a look at this one here. Okay, question 14, applications of functions. One other one to have a look at here, just a logarithmic function. Okay, so you can see very same idea here. The change in pH of the soil after addition of an acidifying agent can be roughly modeled by the following logarithmic function. So P of t is 12 times 1 minus a quarter times the natural log of 1 plus a half t. So again, those fractions maybe bother you, but you know they don't need to. Okay, it doesn't make any difference. Where t has to be equal to 0, where P of t represents the pH. Okay, so that's the pH. And t is in weeks, t weeks, so that's in weeks. Okay, after the acidifying agent was added. So find the initial. Now there's another buzzword, initial. What does initial mean? That's your vocabulary, your dictionary for tomorrow. Initial means at the start, which mathematically means time equals 0. So initial means the time is 0. Okay, so you can see now all I got to do is put t equal to 0 in here, put it down, and we get, pop into your calculator, we get 12. So the pH was 12 when the time was 0. That's the initial pH. No problem there. Part 2, find the pH of the soil after 4 weeks. Look at the number given the question, 4 weeks. Because that's in weeks, it's a value for t. So I know to put t equal to 4. Okay, it's telling me what he wants me to do in the question. Shove in t equal to 4, evaluate it all, and you get 8.7 to one decimal place. So you can see the pH is dropping. So I go down from 12 to 8.7 after 4 weeks of adding an acidifying agent. Okay. Part 3, neutral soil has a pH of 7. So look at the number that's given there. The number 7 is a pH value. Okay, so again, 7 is going in here. Okay, the P of t is pH value. So pH of 7 means put 7 on the left-hand side and solve. See the way the question is kind of showing you what it wants you to do. It's not making it mysterious, guys. He's trying to get your foot in the door here. All right. So if I put the 7 in there, again, what I would have done here, maybe just to make life a little bit easier, just multiply the brackets on the left-hand side here. So 12 by 1 is 12, and then 12 by minus a quarter is minus 3. And now just go through the sequence of steps and move this 12 across on the left-hand side first. So 7 minus 12 is minus 5. Then divide across by this guy. So minus 5 divided by minus 2 is 5 over 3. Just leave it like that. Is equal to natural log. So there's your logarithmic equation there. So I moved the 12 across, divide across by the minus 3. I get 5 over 3 is equal to the natural log of 1 plus a half t. Right? Now, how do I get rid of natural log? Well, remember back here in this previous question here, I got rid of e to the power of by using natural log. So to get rid of natural log, I'll use e to the power of. Remember that. Because most exponential functions will use e and natural log because of how easy the differentiation is. Okay? So to get rid of e to the power of, take the natural log of both sides. To get rid of natural log, go with e to the power of both sides. Okay? They're opposites of one another. So I go with e to the power of both sides here. You can see e to the power of 5/3 is equal to e to the power of this. So on this side here, the e to the power of the natural log will cancel. I get 5.2 is equal to 1 plus a half t. Move the 1 across and then divide by a half. And I get t is 8.6. But again, it wants it in days. So multiply by 7. And that's 60 days. A lot of people just left that as 8.6. And you'll lose a mark. Okay, because your answer is correct, but in the wrong form here. So that solved the equation there, and I get 60 days. So how to solve an exponential and logarithmic equation, it's no harm reminding you of those steps. But again, talking your way to the steps in an equation like that, rather than writing it out, is what you can do to kind of get good at these questions when you've got limited time available to you. And then finally, find the rate. There's your buzzword again, rate. Find the rate at which the soil pH is changing after 10 weeks. So again, rate means derivative. Okay, so if you look at your function here, it's 12 minus 3 times, when I multiply the brackets out there, natural log of 1 plus a half t. Right? So what happens when I differentiate that? Well, the number 12 is a constant. So remember, if you differentiate, the constant disappears. The 12 disappears. Okay, I've written it there as a 0. Okay, but the constant disappears. And here we go again, guys. Number, function, bracket. So the number will stay put. The minus 3 will stay where it is. Function. What happens natural log? Go to page 25. Okay, page 25. What does natural log turn into? There it is there. Natural log turns into 1 over. So page 25 will tell you what happens when you differentiate. Okay, so natural log turns into 1 over. So you can see natural log 1 plus a half t turns into 1 over 1 plus a half t. That's the function done. Bracket, you multiply by the derivative of the bracket because you're differentiating. So if you differentiate one advantages, if you differentiate a half t, you get a half, so you just multiply by a half. Number, function, bracket. Now, you won't be asked to find an average value for a log function because integrating log functions is not on the Leaving Cert course. So you'll only be asked a rate here. You couldn't be asked an average value because the integration is not in the course there. And if you multiply the fractions together, you get this guy here, minus 3 over 2 plus t. And again, shove in a value after 10 weeks, put t equal to 10, and you get minus 0.25 per week. Okay, so again, the pH is dropping at a rate of 0.25 per every week. Okay, that's how fast the pH is dropping there. That's what the rate is. Okay, so that's the applications of functions, right? So we don't have very many questions left, guys. There aren't a huge number of questions. As I said, a bit of sequence of series, bit of financial maths, a little tiny bit more calculus. I'll maybe just do this one calculus question with you, just because I want to finish the calculus before I throw it open to maybe any potential questions. But just when we open the chat again, I said if the questions come flying at me again, we will just have to shut it down again. I can't answer questions if they're coming at me at the rate they were previously. And I'm hoping at least some of the questions you were frantically trying to ask me a moment ago, we've kind of dealt with, or you know we're going to. Okay? So last one here then. Just he hasn't asked a question on a cone now in a while. Okay, on paper 1. There hasn't been a question on a cone in a while. So I'm not predicting a cone. I'm simply saying that, look, if I was setting a Leaving Cert exam paper, I'm kind of saying, well, look, what have I not thrown at them in a while? You know, what maybe catch them slightly off? So if he throws a question about a cone, okay, that's a possibility. And when you're dealing with differential calculus, the volume of a cone is this formula here. Remember, it's in your formula 1/3 pi or squared h. So the problem with this is there's 2 different letters on the right-hand side. That means you can't differentiate it because there has to be only one letter on the right-hand side. Yeah, so to find dv, dor, there has to be just an or on the right-hand side, or dv, dh, just a h on the right-hand side. I can't differentiate when there's 2 different letters over here. That's why cones are nice for calculus, because there's 2 ways I can use a cone to write a formula like this in terms of only 1 letter. Let me show you what I mean by that. Just 2 things to put on your radar. So containers are produced in the shape of right circular cones as shown below. That's an important word, right circular. And it's on the diagram too. I'll remind you of that now. Right circular cones as shown below. The slant height of the cone is 15. Okay, remember that's the slant height of the cone there. That diagonal distance there, L, is the slant height. Right? Now, look at the diagram. Look at the diagram. Why is the diagram here? He has put in a right angle here. That's a huge clue. He's hoping that those of you who are thinking and not freaking out will think, hang on, Pythagoras. It's a Pythagoras question. Okay, so it's a Pythagoras thing. So in this case here, so that's what a right circular cone means. A right circular cone is one where the height, okay, this side here, the height, the radius, and the slant height form a right angled triangle. Now there's the clues, guys. The word right circular cone and the right angle given the diagram, that's the examiner hoping he can point you in the right direction about what to do. Because see what it says, we're told the slant height is 15, so that's 15 there. It says let h be the height of the cone and or be the radius. Express or in terms of h and show the volume is given by this formula here. There's the volume, okay? So express or in terms of h. Well, if nothing else, look at the diagram. Or squared plus h squared equals 15 squared. It's Pythagoras. How do I know it's Pythagoras? He showed me. Short of actually writing the word Pythagoras in the paper, he couldn't have done more. Pythagoras theorem there. So if you use Pythagoras theorem, you'll get that or is equal to the square root of 225 minus h squared. Right? And you can see that's just by simplifying, expressing or, get or by itself, or in terms of h. Just use Pythagoras to bring everything on the same side. Now, doesn't that mean now I can put or, I can replace the or in this formula with this, right? So all I do is I put that in there for or, tidy it up, and I get the volume formula I'm looking for here. Okay, so once I know what or is equal to, replace the or in the volume formula with root 225 minus h squared, and you get the formula you're looking for. And notice, now you've got a formula for the volume of this cone that only contains one letter on the right-hand side. That's the point. So one way I can write one of these letters in terms of the other is by using Pythagoras' theorem. And then the second part of the question, there's your buzzword again. I'm not going to worry about that. Maximum possible volume. So all you do now is you take this formula here, which can now be differentiated, and put the derivative equal to 0. So find dv dh, put it equal to 0, solve the equation, and you get it 5 root 3. And then sub that back into the original formula, this one here, the original formula, to get the matching volume. And you get that the volume is 1360. And again, notice I just checked here, because it's very easy to find the second derivative this time. Let me just check. I don't have to. Like the previous time we had a maximum min problem, because root 75 is either plus or minus 5 root 3. And the minus one makes no sense, because you can't have a negative height of a cone. So because only one valid answer, that's got to be the maximum point we're looking for. But again, this case here, I think I would go ahead and check anyway, because finding the second derivative to see what sort of turning point it is quick and easy. I just have to differentiate this guy here, which is very easy. Just get minus 2h, minus 2 pi h, throw that number in, I get a negative answer. That means it's a maximum point. So I think I would just do it there. Particularly if I'm looking for h1, I'll just show it's a maximum point there, because it's quick and easy to do. It's not like the previous example where I had to use a quotient rule. I can do it like that, right? Part 3 then, this is the other way you can work with the cone. So if I'm dealing with cones, they're the two things I'll be watching out for. First of all, for a cone, the slant height, okay, the slant height, and radius of the cone will form a right angle triangle. So there's probably a Pythagoras waiting for you in there. And the second way is by using similar triangles, right? So notice what we've got here. So it says the container from part 2 above is partially filled with water. So that's the container, this guy here, the one with the maximum possible volume. So it's this one here where the height is 5 root 3. It's this container we're talking about from part 2. It's partially filled with water as shown below. Water is leaking out of the container through a tiny hole in the base at a rate, oh, there we go, special word, rate of 4 pi centimeters cubed per minute. Let x be the height of the water container. Using similar triangles or otherwise, show the volume of the water in the container is given by this here. So again, how can I find the volume of the water here? So again, because the water is in the shape of a cone, volume is 1/3 pi or squared h. I won't be able to differentiate that to find a rate, because there's 2 letters on the right-hand side. So I'm using similar triangles here. Do you see the 2 similar triangles that we're talking about? Similar triangles, remember, triangles are the same shape with different sizes. So we've got this one here, that right angle triangle there, the height, radius, and slant height of the water, and this one here, the height, radius, and slant height of the entire container. There's your 2 similar triangles. And all you need to remember about similar triangles, I'm not re-teaching similar triangles now. All you got to remember is, if you write the 2 radii as a fraction, the 2 heights as a fraction, or the 2 slant heights as a fraction, those fractions are all equal. That's all a similar triangle is. Remember, if you make the corresponding sides into fractions, the fractions are all equal. So when you're dealing with cones, if you make the 2 radii into a fraction, the 2 heights into a fraction, and the 2 slants into a fraction, those fractions are all equal. Okay, that's all similar triangles means. So notice here, if we just fill in the measurements we've got, okay, so we know for the one that we're dealing with here, in this case, the height is 5 root 3, right? So we know that this side here is 5 root 3. Like that red side there. Now, what I would have done first is let me find the radius here. So remember, I can go back up to this line here. Remember what we had earlier on? We had this line here earlier on. So the height is 5 root 3. Put 5 root 3 in there to find what the radius is. Okay? And if I put the corresponding radius in there, okay, I get that the radius, that's what I've done here. Use the Pythagoras theorem. That's 5 root 6. And now that's or there, and that's h there. Sorry, x, they're calling x the height here. So I can just make them into fractions. So you can see if I make the 2 radii into a fraction, or over 5 root 6, that's the 2 radii as a fraction. And the 2 heights, x over 5 root 3, those 2 fractions are equal. Okay, that's all similar triangles means. Right? And you can see I can tie that up there, just multiply across by the 5 root 6, and I get or is root 2x. And then again, you can sub that in here for or, and your volume formula only contains 1 letter and can be differentiated. That's the key thing to be familiar with here. So when you're dealing with cones, that's why he likes cones. Okay, that's why cones are good shapes to work with. He hasn't asked a cone question now in a while. Okay, but that's the thing, that in order to deal with a cone, you need to go from a formula that has 2 letters on the right-hand side down to 1. And there's the 2 ways with a cone you could write one letter in terms of the other. Pythagoras theorem or similar triangles. And we've got an example of both of those there. Okay? So you've got your volume at that. And then find the rate. So notice here, there's, again, rate question. So what we're told here, in the first part of the question, we're told the water is leaking out of the container at a rate of 4 pi centimeters cubed per minute. We're asked to find the rate at which the height of the water is changing. So the word rate is mentioned twice there. Once in the first part of the question here, where I'm told when I'm given a value. And then once again down here in the question. So remember, that's a related rates of change question. The word rate is mentioned twice. Okay, so put that into your toolkit. To mention the word rate, it's a related rates of change question. And remember, that means if I work out the one I know, so the one I know is the one I was given a value for here. And in a related rates of change question, it's 2 measurements the same shape, both changing with time. Okay, so they're both d something dt, changing with time. This case here, look at that, it's 4 pi centimeters cubed per minute. So centimeters cubed is volume, and minutes is time. That's dv dt. So 4 pi there is how the volume is changing with time. Look at the units. Centimeters cubed is volume, minutes is time, so it's volume and time, dv dt. So dv dt is minus 4 pi. Why is it minus 4 pi? Because we're told in the question that the volume, that water is leaking out of the container. So the volume of water is getting smaller. And remember, if something's going down, the rate is the derivative is negative, the rate's negative. If you left the minus sign out, he probably won't penalise that. Do you remember the one a couple of years ago where you had the guy walking towards a street light? And you were told how fast that was. You were walking towards the street light there at a rate of 1.5 meters per second. And he put down that that was 1.5, when in fact, it's getting smaller. Because you're walking towards the street light, so the distance between the guy and the street light is getting smaller. It should be minus 1.5. He didn't bother with the minus sign at all. So the chances are the minus sign there won't be a penalty if you forget it at all. But just if what you're dealing with, what you're given a value for is decreasing, make it negative. Okay, because negative means it's decreasing. And we're asked to find the rate in which the height of the water is changing. The height is x. So we know what dv dt is. Can we find dx dt? So the one we're looking for, dx dt, is the one we know, dv dt, multiplied by, remember, it's going to be this guy on top and this guy below, no exceptions. So dx dv. Because you can see what happened now is the dv's on this side here will cancel, and you'll be left with dx over dt, which is what you're looking for. Okay, so what I'm going to do now is find dx dv. So that's going to involve doing my difference. So I now need a formula that contains v and x. So if the formula you need to do this differentiation is not in the question, it must be in your formula booklet. In this case, it's in the question. So if there was no formula given the question, I'd have to look at my formula booklet. It might tell you, for example, that it's a sphere. So I'll go and find the formula for the volume of a sphere or something like that. So the formula that you need to differentiate now has these 2 letters in there. So if the formula you need is not in the question, it must be in your formula booklet. And you can see there's the question, there's the formula we want there, that v is 2/3 pi x cubed. There's the formula that contains v and x. Okay, so I'll take that formula there. V is equal to 2/3 pi. So differentiated, I get dv dx is 2 pi x squared. Now, why do I flip it upside down? Because I'm looking for dx dv. That's what the linking rate here is. And I've just found dv dx. Because when you differentiate, the letter by itself on the left-hand side here always goes upstairs, above the line. And then on the right-hand side goes below. So I found dv dx. I want dx dv, so just flip it upside down. So 2 pi x squared becomes 1 over 2 pi x squared. And just multiply the 2 of them together. So multiply the one you're given, the minus 4 pi, by the 1 over 2 pi x squared here, and you get this. Now, you don't even have to simplify like that, because you always be throwing in a number. So it says when the volume is 18 pi. So remember that the value of x here is not volume. So I can't put x equal to 18 pi. I need to know the x is the height. So I need to know what's the height of the water when the volume is 18 pi. So again, use this formula here. Your formula of volume. Sorry. Okay, so volume is 2/3 pi x cubed. Okay, so just say, look, I know the volume is 18 pi. So put 18 pi in here on the left-hand side and see what x is. So if I solve down there, pi x cubed, I should say, all right, I get that x is equal to 3. So then just shove x equal to 3 in here and tidy it up, and you get minus 2 over 9 centimeters per minute. Okay, now there's the 2 other applications of calculus. Okay, a max-min problem there and a related rate of change question. But again, just keeping an eye on how you work with cones. Now remember those two things when you're doing cones. Pythagoras theorem, the height, radius, and slant height will form a right angle triangle. And in similar triangles, if you go one cone inside another, write the two radii as a fraction, the two heights as a fraction, the two slant heights as a fraction, those fractions will all be equal. That's calculus. So calculus, algebra, logs, indices, they're the key things there, right? So we've got a couple of questions just to blitz through. We might, Grace, just for our own amusement, Grace, we might just throw the chat on again very quickly. Just see if there's any questions there that I can maybe pull out one or two of while they fly past me. We'll probably have to shut the chat down again because of the rate the questions are coming at. But let's just see what's going on, okay? No, so it's all going bish bash bosh, okay? Okay. Okay, so they're flying here, yeah. Okay, I'm not even able to pick out words here. Okay, it's just a crazy words. I think everybody on the planet is just firing in questions here. So I'm not able to make any questions there, guys, that deal specifically with see. This is how my mind works. I don't know the selective. The only comment I've been able to pick out there was somebody asked me if they can touch my bald head. So maybe Grace at that, but we might just shut it down again there because we'll just leave it that for the moment because I'm not sure we're going to be able to pull out anything there. Whoever was asked me if you can touch my bald head, and no, I guess is the short answer. I mean, I know it's supposed to be lucky, but I'm not sure for who. So no, so we'll just kind of push out just a couple more questions. We've got another kind of maybe 20-25 minutes here, guys. You can obviously you can bail if you need to here, but that's the really big hitter stuff. I just want to have a look at one or two of the shorter questions now. We'll do a quick bit on integration, sequence series, financial maths, and complex numbers. Okay, we'll just blitz those out. I'll do as much as I can in kind of the next 20 minutes. So, but this is what if you even tomorrow, if we don't get to some of these questions here, have a look through the solutions yourself. Remember, don't try and do them out. Just kind of have a look at the steps involved. Okay, so what do I do? How do I do one of these? So if I get turning points, okay, find the derivative, put it equal to 0. Get your x values, put them back into the original formula to see what the y values are. Get your second derivative to check if it's positive or negative. Positive is a minimum point, negative is a maximum point. That kind of thing. Don't try and do the question because it takes too long. Just kind of try and remember what's the sequence of steps in each question. That's the key idea. Okay, so integration, remember, so question 16 there, integration question, we just kind of blitz this. So it says a function defined as follows. So f of x is x cubed plus 2x squared minus 24x. You have to find the area of the shaded region. So we're trying to find the area between a curve and the x-axis. You first of all need your boundary values. Do I know what these boundary values are? Notice here, first of all, there's two separate areas. One above, one below. You've got to find those two separately. So there's two calculations. Anytime there's two separate pieces to the area you're looking for, you must find the pieces separately, always. Okay, because one will have a different sign. You have to drop the minus sign and add them together. Okay, so always find the two areas separately. I need to know what these boundary values are here. Now, in some questions they're given. In this case, they're not. So we're not told what these numbers are, so I've got to find them myself. So what are those numbers there? They're the points where the graph hits the x-axis. And how do you find where a graph hits the x-axis? You put y equal to 0. So all I've got to do is put this thing here equal to 0. And that's what I've done to begin with. Okay, so to find the points where the shaded area begins and ends on the x-axis, just put y equal to 0, put the function equal to 0, and solve. Right? So I just solve that there and I get the three values, 0, minus 6, and 4. So obviously that's 0 there, that's 4, the positive one, and that's minus 6. So I've got my boundary values. So all you're going to do to find the two areas is integrate this formula here between these two numbers to get area 1. Don't just go from minus 6 to 4. Your answer will be wrong. You've got to find the two areas. So integrate between minus 6 and 4. So again, I find my integral. Okay, so if I just integrate, I'm going to add 1 to the power, divide by the power. So if I integrate this guy here, I get x to the power 4 over 4 plus 2x cubed over 3 minus 24x squared over 2. Add 1 to the power, divide by the new power. Okay, so we write that at that. And I just haven't put the values in yet. So the square brackets tell the examiner I've got the integration done, I just haven't put the numbers in yet. Put the bigger number in first, like we did already. I get 0 Put the small number in second, I get minus 6. Put the minus 6, I get minus 252. And then subtract from the other, I get 252. So the area of this bit here is 252. So do you see when I do the integration there, I get a positive answer because the shade area is above the x-axis. That's why I got a positive answer here. We're above the x-axis, right? Now, to find area 2, you don't need to go and integrate again. Just take this integral here and put in the new boundary values 0 and 4. So if I put the bigger number in first, the 4, I get minus 256 over 3. Put the small number 0 in, I get 0. Subtract from the other, I get minus 256 over 3. So see it? So this time I do the integration, I get a negative answer because we're below the x-axis. So you have to manually drop the minus sign because areas can't be negative. So area 2 there is not minus 256, it's 256 over 3. And then add the two of them together, and you get your total area is 1012 over 3. So if you're trying to find the area between a curve and the x, you need to have the boundary values. If they're not given, just put the function equal to 0. That you're going to find the points where a graph hits the x-axis, and then integrate between those two values. And if there's two separate areas as there is here, you're going to have to find those areas separately. Because one of them will have a negative sign when you find the integral. You have to drop the minus sign by hand and add the two of them together. Nice little question, that one. He didn't ask areas last year. Remember, he asked one 2 years ago, the one that kind of had the Adidas symbol. Okay, you were asked to find the area between two curves to give you a shape like that. And that was 2 years ago. Okay, so he didn't ask areas last year, so it's just worth reminding you how to find areas like that. And then that's the area between a curve and the x-axis. What about the area between two curves? Two graphs. Exactly the same idea, right? So again, notice here that this here is the same function we had a moment ago. That's still f of x. That's still our cubic one. That's this guy here. But now we've got the line, this line here, y equals minus 9x. And we're asked to find the shaded area. So again, see there's two separate areas. You've got to find the two of them separately. That's area 1 and that's area 2. Anytime there's two separate areas, you always have to find the two of them separately. Okay? Now, again, this time you can see the boundary values are given. So we're told that we start here at minus 5. That's 0 and that's 3. Okay? How do I know that's 0? Because that's labeled as the y-axis. That's x equals 0. So I'm not assuming that's the x-axis. We're told it is because it's labeled with the letter y there. So the boundary values here are minus 5, 0, and 3. Now, if the boundary values weren't given there, what I would do is is to find the point where the two curves intersect, put them equal to one another. So I would have taken the quadratic one, x cubed plus 2x squared minus 24x. That's the formula for the curve, and put that equal to minus 9x, and solve, right? So if the boundary values, if you got the area between two curves, if the boundary values aren't given, put the functions equal to one another and solve. And that would have given you your minus 5, 0, and 3. Okay, there's my boundary values. So again now, I just have to integrate between these numbers to find area 1 and between those numbers to find area 2. Now, the quick way of doing this is not to integrate the two of them separately and subtract your answers. Subtract them first. So to get the area between two curves, once you've got your boundary values, just subtract one function from the other. It doesn't matter what order you do them in. So there's the cubic graph. Take away the minus 9x. So subtract this from this. Or the other way around. Doesn't make any difference which order you do the subtractions in. Right? And when I do that, I get this guy here. And then integrate that between minus 5 and 0 to find. So you're doing the integration, only doing one integration now, not two separate ones. That'll always work. To get the area between two curves, subtract the curves and integrate between the boundary values. So again, if I integrate x cubed plus 2x squared minus 15x, the answer I got when I subtract one curve from the other between 0 and minus 5, I got this answer here. See the way this time that was 1375 over 2. That's 1375 over 2. And then take the same integral again, but use the new boundary values 0 and 3 to get this number here. Again, see the way one of them is negative? You drop the minus sign, you get 117 over 4. And when you add those two together, you get your total area, which is 863 over 6. So again, if you're trying to find the area between a curve and the x-axis, okay, the two things is make sure you've got the boundary values. If you don't, just put the function equal to 0 and solve. If you're trying to find the points of the graph, it's the x-axis, right? If there's two separate areas, get the two areas separately because one will have a plus sign, one will have a minus sign. Drop the minus sign for the negative one and then add them together. If you're trying to get the area between two curves, it's identical. Except to find the boundary values, don't put the function equal to 0, put the functions equal to one another and solve. That'll give you your boundary values. And then again, if there's two separate areas, you've got to find the two of them separately. Okay, again, as you can see here, one was a positive answer, one's a negative answer. Drop the minus sign for the negative one and add the two of them together. If there's only one area, there's only one integration, one set of boundary values, you're only doing the calculation once. Just question 17 and the last integration question, just because he hasn't asked the trapezoidal rule now since 2015. Okay, so just to remind you of this, the trapezoidal rule, it says a function is defined as follows. There's your exponential function there. Okay, like that. F of x equal to e to the power of 0.25 x over 2. And it says complete the table below. So what you got to just do is throw these values 0, 1, 2, 3, 4, 5, 6 into your table function of your calculator and get the answers, right? So I get 0.5, 0.642, and so on. So just throwing each of these numbers into the formula here using your table function gives me those values, right? Now remember, what you're finding there is that that line there is 0.5. That's that number there. That line there is 0.642. It's that number there, and so on. So these numbers in the table here represent the length of those dotted lines. It's how far the graph is above the x-axis at each of those points, right? So part 2 then says use the trapezoidal rule to estimate the area. So remember, how do you use the trapezoidal rule? It's in your formula book on page 12. But I don't look it up. I remember it like that because it's written in very mathematical language. That's how I remember the trapezoidal rule. It's the width over 2, and the width is how far apart each of these lines are. Okay? Over the first height times the first height plus the last height plus 2 times all the others. So in this case here, that's the first height, that's the last height, and these are the rest in here. And what's the width? The width is 1, because we're going up in ones on the x-axis. So the width over 2 is 1 over 2. The first and last, I put these two guys, 0.5 and 2.241. First place was the last height, and 2 times all the others. And then pop it into your calculator and you get this answer here, 6.9995, which is very close to 7. I'll show you the reason I left it at 6.9995 there, but that's the rough estimate for the shade area with the trapezoidal rule. So he asked this question about 3 times very early in Project Maths and hasn't asked it since, and he hasn't asked the trapezoidal rule since 2015. So it's way overdue. Just want to show it to you here, right? So part 2 then says use integration to find the true area. So find the true area using integration. So use integration to find the true value for the shaded region. So again, integrate. Okay, again, the key idea here is if you look at that, then e to the power of 0.25x over 2. If you want to visualize, pull that half out in front. There's your formula there. They mean the same thing. Because you can see now you can use number, function, bracket, as we've done before, right? So you can see the half stays put here. These were 0.25x stays the same, and then divide by the derivative of the bracket, divide by 0.25. There's your number, function, bracket again. And you sub in the two values, put the 3 in, you get this number here. Put the 0 in, you get that number there. So if you get 6.9634. And if they're very close. So that's the rough estimate we got for the area there using the trapezoidal rule, and that's the true value there. And then to get the percentage error, subtract one from the other, and you just get that, 0.0361. That's the difference between the two. The difference between this true value here and that estimate there. And then always, to get the percentage error, you express the error as a percentage of the true value. And the true value is the integration one. That's the exact answer there. And you can see it's 0.5%, so it's very, very close. Now, that's a question he asked about 3 times. Okay, in the early stage of Project Maths, and hasn't asked this since 2015. But it's a lovely application of the trapezoidal rule and testing your ability to integrate as well. Okay, nice little question, that one. Okay, that's integration. Now, I said just 2 things then to look at just to finish up. Sequence of series, which includes financial maths and the complex numbers. I might just do the complex numbers first, because if I don't get the sequence of series done, if we don't get everything done, I said we might get everything done, guys. We've only got about 15 minutes left because I'm not going to keep you all night. I do want you to make sure you get a decent night's sleep. But I will just have a quick look at the complex numbers because it's quite short, quite quick. And then if I don't get a chance to look at the sequence of series there, you can have a blitz through them yourself. I've done sequence of series of financial maths very recently anyway with the with our classes, so I'm not too worried if we don't get a look at that. You could glance over them yourself anyway. As I said, doing the entire course in one evening is hard going. But we've had a look at a lot of this. So we've had a look at the big stuff, the algebra, logs and indices, differential calculus, integration. Okay, and that's going to be a big chunk of your paper tomorrow. Okay, a really big chunk of your paper, and we've put kind of a lot of the important stuff back on your radar and really spoken about how to go about the paper. Don't be afraid to get stuck in. Okay, look for these buzzwords that tell you what to do. The paper will be littered with them. Okay, so if you have nothing else, we've kind of established that how to go about the paper and what to watch out, what will tell you how to go. And remember, don't be alarmed by questions you haven't seen before. There will be questions you haven't seen before, but nobody else has seen them before either. You're just as well equipped as they are to have a go at that. So don't be afraid to try something. Read the question, look for any of these buzzwords that might tell you what the question's dealing with, and get stuck in. Right? So look at question 21. This complex number question, where it says z is the complex number 6 plus 7i over 1 plus 2i, where I squared is minus 1. Show that that's one root of this equation here. Okay. So first of all, remember, when you see a complex number in fraction form like that, your first step is to turn it out of a fraction. Remove the fraction. He asked this at the very first part of the complex number question last year, so he may not ask it again. Remember, what you do there is you multiply top and bottom by the conjugate of the bottom. So the conjugate of 1 plus 2i is 1 minus 2i. Multiply top and bottom by 1 minus 2i, and it simplifies to 4 minus I. Okay, so the moment you see a complex fraction, multiply top and bottom by the conjugate of the bottom. It's the conjugate of the bottom. It's the number below the line you want to make into a real number. And it'll simplify down, in this case, 4 minus I. So how do I show it's a root, like we met earlier on, and we were doing factor theorem? To show it's a root, put z equal to 4 minus I, and just algebra the shit out of it. So if I put z equal to 4 minus I and just multiply out all the brackets, I do get 0. So it does work, therefore it is a root. So that's not too hard to do. So turn a complex fraction into a normal complex number that's not a fraction by multiplying top and bottom by the conjugate of the bottom. Okay, and then to show it's a root, throw it in for z and show that you get 0 as an answer. Not too hard to do. Now, how do you find the other root? That's what I want to put on your radar here. So this thing here, make sure you remember that for tomorrow. For any quadratic equation, okay, you can write it in the form x squared minus sum of the roots times x plus the product. So if you've got this equation here, we've met this one before, x squared minus 5x minus 14 equals 0. Remember that if you solve that, it's x minus 7 by x plus 2. So that's x equals 7, and that's x equals minus. So they're your two roots, right? So they're the two roots there. And notice, if you multiply the two roots together, you get minus 14, the number in the end here. So the number on the end is always the two roots multiplied together. And look, if I add the two roots, 7 plus minus 2 is 5, and then change the sign, I get minus 5. That's the number for the x here. So for every quadratic, the number in the end is the two roots multiplied together. And the number for the x, or the z, if it's a complex, it doesn't matter what letter it is the two roots added together with the sign changed. Don't forget this, that's the minus sign there. Okay, so that's the important one. The number for the in front of the z is the two roots added together with the sign changed. So see what that lets me do here. Okay, in the case of this question. So I know already, don't I, that 4 minus I is one of the roots, because I showed that already. I want to find the other one. Let's call the other one a plus bi for a second. If I add the two roots together, I should get this number here with its sign changed. That's the shortcut, see it? The number for the z with its sign changed. So if I change the sign, just drop the minus sign, that should equal 7 plus I. And now it's all over. Because a lot of people kind of do that one, and it's not wrong, by maybe using the minus b formula. A is 1, that's b there, and that's c. Put them with the minus b formula, and 4 minus I will be one of your roots, and the other answer will be the other root. That's fine, but it's a lot of work. This is a very, very useful trick for complex numbers. Okay, it works because if you're familiar with the conjugate roots theorem, a lot of people aren't sure when they can use that and when they can't. So always use this, because this will work whether the coefficients are real or not. This will always work. So for complex numbers, whether the conjugate roots, remember the conjugate roots theorem would apply if these three coefficients, if you had one of this z squared minus 2z plus 11, because a, b, and c are all real numbers. That means that the roots are going to be conjugates of one another. So 4 minus I was a root, 4 plus I would be a root. That's the conjugate roots theorem. But you can see that doesn't apply here because this is not a real number, neither is that. So a lot of people kind of aren't sure when they can use the conjugate roots theorem. So don't bother. Because even in a question like this, the method we're looking at here will work. Right? So now just put the real parts equal. So that's real, and that's real. See, I get 4 plus a equals 7. So a is 3. And then that's imaginary, that's imaginary. Put the imaginary is equal as well. I get minus 1 plus b is equal to 1. I get b is equal to 2. So then put those values 3 and 2 back in here. The other root's 3 plus 2i jogging on. That's one thing to make sure you've got for complex numbers. Have that at the back of your mind. That's how I deal with those roots of complex roots in the equation. Okay, that guy in yellow there is very, very useful. Worth its weight in gold. Right? Then part 2, you can see here, you're given that z squared plus 2z times z conjugate is equal to p plus qi, p plus pq plus qi, where p and q are elements of z. Find the value of b, of p and the value of q, right? So z, remember we found z already. Z up here, we're told z is this guy here. So z is 4 minus I. I'm pretty sure in a leaving cert question he would remind you. He said reminding you that z is equal to 4 minus I. He'd remind you that the z here is the z in the previous part of the question. I think he'd probably remind you of that, so you're not in any doubt. So you can see z squared, well that's fine. I'll just put in the 4 minus I squared here, no problem. Right? And then 2 times z by z's conjugate. So remember that's 4 minus I by 4 plus I. Z conjugate, remember the bar over the top there is change the sign for the imaginary part. So if you just do the algebra there, I can work out what the left-hand side is. So z squared plus 2z times z conjugate, that simplifies to 49 minus 8i. So I'm just putting z and its conjugate in here and doing the algebra on the left-hand side. Okay? And that gives you 49 minus 8i. And then that's equal to p plus pq plus qi. So again, when you've got complex numbers on both sides, put the real parts equal and put the imaginary parts equal. So the same thing, you can see I put the real parts equal. I get 49 is equal to p plus pq. Okay? There's that line there. And imaginary parts equal minus 8 is equal to q. So see straight away I've got my value for q. Minus 8 is equal to q, so q is minus 8. And I just put that value for q in here and solve. I get my value for p is minus 7. So it's very, very easy bit of algebra there once I know what to drop in. But that idea there where you're putting the real parts, imaginary parts on both sides equal, watch out for that. Okay, anytime you've got a line where you've got a complex numbers on both sides of an equal sign, put the real parts equal, the imaginary parts equal, that's very often where your solution will come from. And then if nothing else on complex numbers, okay, de Moivre's theorem. Now, remember there's 3 applications of de Moivre's theorem. There's solving an equation, there's proving an identity, and there's finding a power. Now, 2 of those he examined last year. He did the trig identity last year and the solving an equation. So I think the smart money for tomorrow is probably on finding a power, the easy version. Okay? So look at this question here. It says z is minus 1 plus I root 3. Okay, that's a complex number. Use de Moivre's theorem to evaluate z to the power of 9. So all you're doing there is raising it to a power. Okay, that's the easy version. That's the one we might be getting tomorrow. Just do a power. It's the one he didn't examine last year. The only one he didn't examine last year. It's almost, well, it's pretty much guaranteed you'll get a de Moivre's theorem question. There hasn't been a complex numbers question in the history of Project Maths without de Moivre's theorem being half the question. Right? So it'd be a major departure. I'm going to catch everybody out if he doesn't test it. Okay? The question is, which application does he test? I think it's probably going to be a power. But power and an equation don't make a great deal of difference. Right? So remember, what you're going to do first is put it into polar form. So make sure you can put the complex number to polar form. I've reminded you how to do it there. And find them, just draw your argon diagram. Find the modulus, find the argument. Make sure, if you're not sure to put a complex number in polar form, check that. Have a look at that in your textbook. How to put it into polar form. Make sure be clear that it's absolutely 100% fine to do that using your calculator. So I've been asked that by a few people at seminars during the year, and my teacher showed me to find polar form using my calculator. Is that okay? Absolutely. Look at the past marking schemes. It'll tell you or and theta found with no supporting work gets full credit. So it's okay. The only danger is if you write down complex polar form wrong, he can't give you partial credits for showing you knew how to find it. Okay, but if you can find polar form reliably using your calculator, he will give you full marks for that. So I put the complex number to polar form first. So minus 1 plus root 3i is 2 times cosine 120 plus I sine 120. So find or, find theta, and then that's the polar form there. Right? So remember, or is how far the complex number is away from 0, and theta is the angle that forms the positive x-axis. And it's perfectly okay for it to be in degrees. It doesn't have to be in radians. Degrees is absolutely fine. Right? So then to raise the power of 9, okay, I want to do this, so it's 2 times cosine 120 plus I sine 120. And I'm trying to raise that to the power of 9, right? So what you do, remember, is you apply the power here, you apply the power to or, and you multiply the power by this angle. That's all de Moivre's theorem is. So when you're raising complex numbers to a power, apply the power to or, the number out in front here, and then multiply or by the angles in here. Okay, that's the idea. So you can see if I do that here, then I get 2 to the power of 9, which is 512, and then 9 times 120 is 1080, and then multiply your brackets out there. So cosine 1080, your calculator will tell you is 1, sine 1080 is 0, multiply the brackets out, you get 512. So just put the complex number to polar form, hit it with de Moivre's theorem by applying the power to or and multiplying the power by the angle, and use your calculator to multiply the brackets out and get your answer. Very, very straightforward once you know how to put it into polar form, right? So I know we're kind of, I just want to rush in to finish up here. I'll be doing another one of these on Sunday, but the one I'm doing on Sunday is in person. So I'm down the top of the Answer Organ, so premium members can sign up for seeing that. And we've got a bit more time. I'm going from kind of 10 until 2 on Sunday. I'll talk about what paper 1 was like, and we'll go through all the topics of paper 2. We'll have a bit more time there, so we'll actually be doing out some questions on Sunday. We're a little bit short of time this evening because obviously you've got geography tomorrow as well, and you've been doing exams all day. So you've had to kind of condense this and rush it a little bit. Okay, I'm just trying to make sure I touch base with all the topics you guys are most concerned with. But on Sunday, we have a bit more time. We'll be able to spend a bit more time on it on Sunday. Again, it'll be streamed free to the YouTube channel for anybody who's not a Grind 60 member. But the members can come down to the Talbot slogan if you like, for a final kind of in-person workshop while we go to this. And I'll be available then to answer any questions afterwards that you might have. So just, if we did get another equation, can I just show you a shortcut here? Okay, maybe just by way of finishing. I don't think I'm going to get to the complex of the sequence series financial maths. I'm not too worried. It's the only thing we didn't really touch on. I've done an awful lot of what's going to be on the paper tomorrow, I think. All right? But if you did get the equation version here, okay, it's the very same idea, okay, with one change. Now, this is the one that has general polar form in there, okay? So dealing with general polar form, this line here. You can avoid that if you want to. Let me finish, as I said, final question then. Let me finish on this and throw that out there as a shortcut, right? Then I'll maybe open the chat up for a couple of minutes and see if I can pull out some questions to answer at this stage. Because obviously we won't have time to do any more questions. Just if anybody's any last minute questions, we'll throw, when I finish this question, Grace, maybe just for about 5 or 10 minutes, because I think we've got the stream until 9:45. If anybody's any questions, I'll find them. So when I finish this question, I'll see if I can pull out some questions to answer. All right? But just the final one here. If you're asked to solve this equation, so use the one time to solve this equation here, z squared is equal to 2 minus 2 root 3i. First of all, I get the z by itself. So to remove the power of 2 on that side, we go power of a half on both sides. Okay? Remember that if you've got z squared to the power of a half, you've got that rule of indices that tells you if you've got a number to one power and you raise it to another power, you multiply the powers together. So 2 times a half is 1, you just get z like that. So I go with z to the power of a half here, I just get z. So I go with z to the power of a half here. So there's my complex number to the power of a half. See, the only difference now is it's a complex number to a power, but the power is a fraction. It's the only difference when I'm solving an equation. So I get the z by itself, I'll have a complex number to a power that's a fraction. Rest of the question's identical. Put this guy here into polar form, using either your calculator or by using the diagram. So I get this down here. There it is in polar form, like that. And now, when you get into polar form, let's say you don't want to do general polar form. You keep forgetting how to use that. Don't bother. Just do it like we did a moment ago, right? So we'll hit with de Moivre's theorem now. So I get 4 to the power of a half times cosine a half of 300 plus I times the sine of a half of 300. See, because I'm applying the power of a half here. So I put the complex number to polar form to get this line here. And I now want to raise it to a power of a half. So I put the power of a half here and here. Right? So 2 to the power of a half is 4 to the power of a half is 2. And I get cosine 150 plus I sine 150. Right? There we go. And then just evaluate this, multiply the brackets, and I get this answer here. Minus root 3 plus I. Right? So I've got my answer. Now, when you're solving an equation, remember, whatever the power here is, that's the number of answers you're looking for. So I want 2 solutions, I've only got 1. That's all general polar form is for. To give me my second answer. So can I find the other answer without having to go through general polar form? Yes, I can. The benefit of doing it this way is if you forget about general polar form and just polar form, hit it with de Moivre's theorem and multiply the brackets. That'll give you the correct answer completely if you're just doing a power one, which is what we might get tomorrow. If I'm doing an equation, it'll give me one of the right answers. So I'm going to get the high partial if I don't do anything else. How do I find the others? Well, just take a full circle, which is 360, and divide it by this number, the power. So 360 divided by 2 is 180. All you got to do now to get the other answers is just add this number here to this and evaluate. See if I say, look, so if I add when I get cosine 150 plus 180, that's 330. Plus I sine 330. Work that out, that's my second answer. If I needed the third answer because the power here was 3, I'd add 180 again there and evaluate my answer, right? So the number of answers you're looking for is the same as the power. So in this case, because the power is 2, I want 2 answers. So I just found 1. So I just divide a full circle, 360, by whatever the power is, okay, and add it on here. You can see if the power here was 3, if the power there was 3, I'd be saying, right, I get this answer here, my first answer. Got that answer worked out like that, okay? I'd say 360 divided by 3 is 120. So I'd add 120 here to get 270 and work that one out. I'd add 120 again to get 390, work that one out, and that'll be my 3 answers. So you don't need general polar form. If that's a sticking point for you in de Moivre's theorem, you don't need it. Just stick with polar form. Hit it with de Moivre's theorem, multiply the brackets. If you're doing a power question, that will be your answer. If you're doing an equation question, just do that and see if you can remember that extra step to get those last 3 or 4 marks, okay? Divide a full circle by whatever the power up here is, because that's the number of answers you're looking for. And whatever answer you get there, just keep adding that to this angle here and evaluating your answers till you get the number of solutions you're looking for. That's how we'll do it. That's what I'll be looking for de Moivre's, for complex numbers tomorrow, guys. Okay, how to work with roots of an equation and how to work with de Moivre's theorem. So my apologies that I didn't get to sequence a series of financial, but you could glance through those yourself anyway. Again, just reminding you of the key steps. I'm hoping that we've kind of clarified a little bit of stuff for paper 1 tomorrow. Okay, maybe at least giving you an approach to go there, things that are likely and not likely, maybe how to attack the paper. What we might do there, Grace, because I won't be doing any more questions. I don't have time, guys. I apologize. I don't have time to do any more questions. But if anybody's any other questions there, you can maybe fire them into the chat. The chat, I imagine, will have slowed down now. If you don't have any other questions to throw into the chat, then I said just trying to have an early night tonight. Okay, maybe if there's a question there you want to have a glance over, do so now. Okay, but try and have an early night tonight. And tomorrow, as I said, we've gone through at the beginning of the class how to tackle the paper. Don't be afraid of it. Just get stuck in, and we'll see how you're getting on. Okay. So if you have any other questions, you can throw them into the chat there. I'll try and answer them. Otherwise, have a very good night and the very, very best of luck tomorrow, guys. There's a lot more maths in your head than you think. Okay, just let it out. Don't be afraid to show it. Flex tomorrow. Okay. Any other questions? As I said, we'll. So financial maths, there's a few people throwing it in there. It's possible it could be a short or long question. It's not a guarantee. It's possible it could be a short or long question because it hasn't been on the paper as a longish question for a couple of years. So it's possible it might be worth looking over, but don't panic with stuff you haven't looked at. Consolidate the stuff that you have. Lean to the stuff that you have. Okay? Okay, thank you guys. See a lot of thanks there. I'm hoping that it's helpful, guys. Yeah, there's still a lot flying past me here. Whooshing past me there. Somebody asked me about the sum to infinity proof. The sum to infinity proof, guys, is actually there as part of question one of the questions here. So the first sequence of series question there. See it, question 18. The first part 1 there, that's the sum to infinity proof. So if you don't have a copy of that there, question 18, part 1 is the proof of the sum to infinity formula. Just those 3 or 4 lines. The only proof paper one he hasn't examined yet. Okay, just seeing the word induction flying past me there. As I said, it's like somebody, a Labrador with its head out the window of a car that's going past at 90 miles an hour. Induction, it would be, for me, I don't kind of think induction's particularly likely tomorrow because he examined it last year. It's not usually examined back to back. That doesn't mean it won't be on the paper. But I mean, you're not going to learn induction tonight anyway. You've already made your decision about whether you're learning induction or not. Okay, so if you've covered induction, certainly keep a look over it tomorrow just in case. If you're not doing induction, don't try and do it tonight. Don't try and learn any new stuff tonight. Consolidate the stuff that you already know. Don't try and learn new stuff. You've more than enough in your head, guys, for the paper tomorrow. I love this because I'm trying to snatch words here as the chat flies past me. There's like 2 million questions flying past me here. I'm just looking for the odd word here and there. Whoosh, whoosh, bang, crash, bang. No, you can't bring your own log tables in. Okay, because you'll just fill them with cheat notes. So you'll be given a copy of the formula booklet. You need to bring obviously a red or black, a black or blue pen to write with, a pencil, a dark drawing pencil if you want to draw graphs or anything like that. Okay, make sure you bring your calculator, for heaven's sake. You can bring more than one if you want to. Okay, if you need to, if you're worried about the battery in one, and bring your geometry set in case there's a root 2, root 3 construction. Okay, the ones he has that can be asked on paper 1. Okay, so they're the things to make sure you bring with you. Okay. Bosh. I mean, maybe you guys have been watching the chat build over the, but I'm just seeing the chat now. It's literally flying past me here at 1,000,000 miles an hour. Okay. I think somebody said there, de Moivre's theorem proof. I mean, again, it's possible. Okay, that prediction, as I said, prediction is a fool's game. Okay, if you consider you're kind of saying, trying to predict stuff like this, at this stage it's pointless anyway, because I mean, you're not going to be learning anything new now or unlearning something you chose to learn earlier on. So the advice here, what we've been doing all night, is just kind of show you, look, here's the maths that's in your head. Just focus on making sure that your tools for tomorrow are sharp and shiny. Everything that you've learned how to do, you're going in confident in your ability to do, and then just trust your instincts. When you read a question, okay, that reads to me like a calculus question, okay, do it as a calculus question, see how you get on. Don't be afraid of it. Okay, there's an awful lot more maths in your head, guys. Just don't be afraid to show it. The questions are full of clues, going to push you in the right direction. Just relax. Get in there, take a deep breath, make your subject, your question choice at the beginning, and don't freak out. You're going to get a lot of questions that you recognize. I've seen those before, I've done those before, I can do those. That'll get you started, get you settled. And then just see how you get on with the ones you're less sure how to do. Okay? I've already said, guys, I spent the first 20 minutes of the class talking about timings. Okay, so if you missed that, we put the recording up, you can have a look at the timings there. I've been through that already. Okay, how to approach the paper. I don't have time to do it again. We spent the whole first part of the class talking about timing. This is, I love this. Amaze. Just flying, they're flying past me here. I'm just trying to pull out, I've just seen the word timing popping up a few times there. Okay. Okay, Grace, I'm not sure I'm going to be able to pull it in there, Grace. So again, they're just coming, they're flying past me there at like a bullet train. So my apologies, guys, that I can't actually answer any individual questions there. There's simply, as I said, the quantity of questions is just through the roof. They're just flying past me there. I'm only catching words here and there. All right. So just to remind you, just by way of finishing up, all right, that if you did miss the early part of the class, as I said, when you make your choices on your 8 questions, only aim to do 5 short and 3 long. Don't aim to do more than 8 questions. Okay, you might get time to do a 9th or 10th, but wouldn't aim for that. Pick your 8 questions and then do them in the order in which you're confident your ability to do so. Normally, it's about kind of 13, 40 minutes for a short question, 25 for a long question. It's not going to work out that way. If you know how to do the question, you'll do it in a lot less. So if you kind of say, look, I'll start off with the questions I know how to do. I know how to do this long question. Okay, I've got 25 minutes to do it, but I'll do it in 7 or 8 because I don't have to stop and think, right? The extra 13, 14, 15 minutes you've got there goes into your clock for later in the paper when you're doing a question you have to spend more time thinking about. So pick your 8 questions and then do them in the order which you're confident your ability to do so. Do your best question first, whether it's a long or short question. Your next best question second, whether it's a long or short question. And work your way through the paper that way. What you'll find is you'll do the first chunk of the paper. You'll do a big number of the questions very quickly because you know how to do those. You won't have to stop and think. And then when you're doing the questions later in the paper where you're not sure what you're doing, you have to stop and chew your pencil a bit more. You'll find you have a lot more than 15 minutes for a short question, or a lot more than 25 for a long question because you haven't used much of your clock in the first part of the paper. And it does mean that if you did run out of time, you'd run out of time while you're doing a question you weren't sure you were going to be able to answer well anyway. You're not going to do that thing where I ran out of time answering a question that I would have got full marks on. So your best questions first and work your way through the paper that way, all right? And as I said, if you're not afraid to get stuck in, there's huge amounts of maths in there. Most questions have multiple ways of doing it. Don't be afraid to give it a go. Don't leave blanks. Get in there and try something. Remember, you're as well equipped as anybody. There will be questions that you haven't seen before. Nobody's seen them before. They're in the same boat you are. Give it your best shot, and you'll be surprised, I think, how much you get done. you're probably going to come out of the paper tomorrow feeling like you didn't do as well as you hoped. It always happens with a math paper. Why? Because you fixate on the stuff you didn't answer well and you forget about all the stuff you did early on which you answered well. Okay? So when you come out of the paper tomorrow, don't start doing that post-mortem, pulling it apart, asking people, what did you get for question 4? Okay, so there's a punch up in the car park between 3 people who got different answers for question 4 and can't decide who's right and who's wrong. Don't worry about that. Paper 1 is over, draw a line under it, forget about it, and start thinking about what am I going to do now? How am I going to get myself ready for paper 2? Remember, paper 2, we'll take care of you for paper 2 Sunday morning from 10 until 2, either in person or online, depending on what you want to do. We'll do a much more kind of slower. We can spend a bit more time on paper 2 because we're not trying to squeeze into a single evening when you've got an exam in the morning. Okay, so we'll have you buzzing for paper 2. Outside of that, guys, I hope you found that a little bit helpful. It kind of plugged some of the gaps. Any of the questions we didn't have a look at here, maybe skim through them if you get a chance this evening or early in the morning. And as I said, the very, very best luck. I hope it goes well for you. Okay? Now go to bed. Go to bed. Have an early night.